Producing millions of bottles of Pepsi every single day requires an extreme level of precision and cutting-edge technology. Inside massive factories, high-speed machines mix the perfect blend of carbonation and sweetness before bottling and sealing at lightning speed. In this documentary, we take you inside the Pepsi production process, revealing the engineering behind one of the world's most popular soft drinks. The process of making Pepsi begins with one of its most essential components, water. Water forms the majority of the final beverage, making its purification and preparation one of the most critical steps in the manufacturing process. PepsiCo takes extreme care in sourcing and treating water to ensure the final product is free from impurities, contaminants, and off flavors. Without this careful preparation, the beverage could have inconsistencies in taste, appearance, and carbonation retention. The journey starts with sourcing water from natural springs, municipal supplies, or underground wells, depending on the bottling plant's location. However, regardless of its origin, this water must go through extensive treatment to meet PepsiCo's strict quality standards. The process begins with initial screening, where water passes through coarse filters that remove large particles such as dirt, sand, and debris. This is followed by sedimentation, a method that allows heavier impurities to settle at the bottom while the cleaner water moves forward in the process. Once the larger impurities are removed, the next step is carbon filtration. This step is crucial for removing chlorine, organic compounds, and any unwanted odors or tastes that could interfere with the Pepsi formula. Activated carbon filters contain a highly porous material that traps chemical impurities while allowing pure water to flow through. This process not only improves the taste of the water, but also enhances its ability to mix well with the other ingredients later in production. But up next is the reverse osmosis process, one of the most advanced purification techniques used in beverage manufacturing. Reverse osmosis involves forcing water through an ultra-fine membrane under high pressure, effectively removing even the tiniest dissolved particles, including salts, minerals, and microscopic contaminants. This ensures that the water is as pure as possible before it becomes part of the Pepsi formula. To further refine the water, it undergoes ultraviolet sterilization. This step is essential for eliminating any remaining bacteria, viruses, or other microorganisms that could compromise the safety and shelf life of the beverage. High-intensity UV light disrupts the DNA of these microorganisms, rendering them inactive without the use of chemical disinfectants. Finally, before the purified water is stored, it goes through an ozonation process. Ozone, a highly reactive form of oxygen, is injected into the water to act as a natural sanitizer. This step ensures that the water remains free from microbial contamination while it is held in large stainless steel storage tanks, awaiting the next phase of production. Now that the water has been meticulously purified, it must be precisely balanced to create the ideal base for Pepsi. Even though reverse osmosis removes most dissolved solids, a controlled amount of specific minerals is added back into the water to optimize taste and improve its ability to retain carbonation. This step is carefully monitored as the mineral composition of the water can impact the final mouthfeel and texture of the beverage. With the water fully prepared and stored in sanitary tanks, it is now ready to be mixed with the other key ingredients that will give Pepsi its distinctive flavor. But before moving on to mixing, each batch of purified water is rigorously tested for quality. Samples are taken from the storage tanks and analyzed in PepsiCo's in-house laboratories. Scientists and quality control experts measure pH levels, mineral content, and overall purity, ensuring that each batch meets the company's global standards. If any irregularities are detected, the water is either reprocessed or discarded, preventing any inconsistencies from affecting the final product. Now that the water has been meticulously purified and stored in sanitized tanks, the next crucial step in the Pepsi manufacturing process is the preparation and addition of sweeteners. Sweeteners play a fundamental role in defining the flavor profile of Pepsi, contributing to its signature taste while also affecting mouthfeel, viscosity, and overall balance. The selection, processing, and precise blending of these sweeteners are critical to ensuring that every bottle and can of Pepsi maintains consistency across different production facilities worldwide. In most regions, Pepsi is sweetened with high fructose corn syrup, a liquid sweetener derived from cornstarch. However, in some markets, particularly in countries where cane sugar is more widely available or preferred, sucrose from sugarcane or sugar beets is used instead. Regardless of the source, the sweetener must be carefully refined and processed before being added to the beverage. The journey of high fructose corn syrup begins with corn milling, where harvested corn is cleaned, steeped, and ground into a slurry to separate the starch from the fiber, protein, and germ. The extracted starch is then subjected to enzymatic processing, where it is converted into glucose. A second enzyme is introduced to transform a portion of the glucose into fructose, increasing its sweetness. The result is a thick, viscous syrup that is then further refined, filtered, and tested to ensure the correct balance of glucose and fructose. The most commonly used variety in soft drinks is HFCS 55, which contains approximately 55% fructose and 45% glucose, closely mimicking the sweetness profile of cane sugar. For regions that use sucrose instead of HFCS, the sugar is derived from either sugarcane or sugar beets. Sugarcane is harvested, crushed to extract juice, and then boiled to concentrate the sugar, forming crystallized sucrose. Sugar beets, on the other hand, are sliced and soaked in hot water to extract sugar, which is then purified and crystallized. In both cases, the raw sugar undergoes extensive refining to remove impurities and ensure a uniform, pure sweetener. Once the sweetener is ready, it must be dissolved into a concentrated syrup before being mixed with other ingredients. In a dedicated mixing tank, the high fructose corn syrup, or dissolved sucrose, is blended with purified water in precise proportions to create a uniform sweetening solution. This syrup is continuously agitated to prevent crystallization and ensure a consistent texture. To maintain Pepsi's exact sweetness level, refractometers are used to measure the syrup's sugar concentration, ensuring it falls within the specified range. At this stage, the syrup is also subjected to rigorous quality control testing. Laboratory technicians take samples from each batch and analyze them for purity, consistency, and microbial safety. Any inconsistencies in sweetness or viscosity could alter the taste of the final product, so adjustments are made, if necessary, before moving on to the next step. Now that the sweetener has been perfectly prepared, it is time to introduce the key flavoring components that define Pepsi's distinctive taste. Pepsi's flavor is the result of a complex blend of natural and artificial flavorings, including citrus oils, spice extracts, and caramel notes. The exact recipe remains a closely guarded secret, known only to a select few within the company. But it is widely understood that ingredients like orange oil, lemon oil, vanilla, cinnamon, nutmeg, and cola nut extract contribute to the drink's signature profile. The flavoring components are carefully blended into a concentrated mixture known as the flavor base. This highly concentrated liquid is prepared in a separate, sterile mixing tank, where precise measurements of each ingredient are combined under controlled conditions. Some of these ingredients, particularly the essential oils, must be emulsified using stabilizers to ensure they mix properly with the water-based formula of Pepsi. Without proper emulsification, the oils could separate from the rest of the beverage, leading to inconsistent flavor distribution. Phosphoric acid is then added to the flavor base, providing Pepsi with its signature sharpness and tangy aftertaste. This acid also plays a crucial role in preserving the beverage by inhibiting microbial growth. The level of acidity is carefully controlled to balance the sweetness of the drink and enhance its overall flavor. Caramel color, which gives Pepsi its deep brown hue, is another essential ingredient added at this stage. This colorant is created by heating sugar compounds under controlled conditions, resulting in a stable and safe coloring agent. The intensity of the caramel color is strictly regulated to ensure that every bottle of Pepsi has the same visual appeal. Once the flavor base is complete, it must be thoroughly mixed with the sweetener solution to create the final syrup that will be used in the soft drink. This blending process takes place in large stainless steel tanks, where high-powered mixers ensure even distribution of all ingredients. The proportion of sweetener to flavor base is precisely measured, as even a slight deviation could alter the taste of the final product. Before the syrup is approved for use, samples are taken and analyzed in a quality control lab. Tests include pH measurement, viscosity checks, and sensory evaluations, where trained tasters confirm that the syrup matches Pepsi's standard flavor profile. These rigorous quality checks ensure that every batch of syrup is identical, maintaining Pepsi's global consistency. Once the syrup has passed all quality control tests, it is stored in temperature-controlled holding tanks, ready to be mixed with carbonated water. These tanks are kept under strict sanitary conditions to prevent contamination and preserve the integrity of the syrup. But up next is one of the most critical aspects of the Pepsi production process: carbonation. This step is responsible for the effervescence and refreshing sensation that consumers associate with soft drinks. Without proper carbonation, Pepsi would lose its signature fizz, altering the drinking experience. The process of infusing the beverage with carbon dioxide is both a science and an art, requiring precise control over temperature, pressure, and gas concentration. To begin the carbonation process, purified water is first chilled to near freezing temperatures. The reason for this is that carbon dioxide dissolves more efficiently in cold water than in warm water, ensuring maximum carbonation retention. The chilled water is then injected with high purity CO2 gas under controlled pressure, creating carbonated water. This water is then carefully blended with the pre-mixed syrup in an exact ratio, typically around 5 parts carbonated water to 1 part syrup. The precise proportion ensures the correct balance of flavor, sweetness, and fizziness in the final beverage. Maintaining the right level of carbonation is crucial, as it directly affects the mouthfeel and shelf life of the product. If the carbonation is too low, the drink will taste flat and less refreshing. If it is too high, the beverage may be overly acidic or cause excessive foaming during packaging. To ensure consistency, carbonation levels are continuously monitored using pressure sensors and dissolved CO2 analyzers. The newly carbonated Pepsi must now be handled carefully to prevent the loss of carbonation before packaging. At this stage, the beverage is kept under constant pressure in specialized holding tanks to maintain CO2 solubility. Any sudden release of pressure could cause the carbon dioxide to escape, resulting in a less fizzy drink. With the Pepsi now fully mixed, carbonated, and held under precise pressure conditions, the next step is bottling and packaging. This is one of the most intricate parts of the manufacturing process, requiring extreme precision, speed, and cleanliness to ensure that every bottle and can of Pepsi is filled, sealed, and prepared for distribution without losing carbonation or quality. The bottling process must take place in a sterile environment to prevent contamination, and the machinery involved operates at incredibly high speeds to keep up with global demand. The first part of this process involves the preparation of bottles and cans. Pepsi is available in a wide range of packaging formats, including glass bottles, aluminum cans, and plastic bottles made from polyethylene terephthalate. Each type of container has its own preparation requirements, but all must be thoroughly cleaned and sterilized before being filled. For plastic bottles, the process begins with small, preformed PET molds called preforms. These preforms are heated to a specific temperature and then rapidly inflated using high-pressure air inside a blow molding machine. This machine expands the preforms into their final bottle shape, ensuring uniform thickness and durability. The freshly molded bottles are then conveyed into a high-speed rinsing station, where they are thoroughly washed with filtered water and food-safe sanitizing agents to remove any potential contaminants. Glass bottles undergo a more rigorous cleaning process since they are often reused. They are first soaked in a high-temperature caustic solution to break down any residue from previous use, followed by multiple rinses with clean, filtered water. Finally, they pass through a steam sterilization chamber to ensure that no microorganisms remain. Aluminum cans, on the other hand, arrive at the bottling plant pre-formed and ready to be filled. However, before filling, they are sent through a high-pressure air jet cleaning system that blasts away dust and debris. Since aluminum cans are highly sensitive to corrosion, a thin food-safe lining is applied inside each can to prevent any reaction between the beverage and the metal. Now that the bottles and cans are fully prepared, the filling process can begin. The carbonated Pepsi is transported through a network of pressurized stainless steel pipes that maintain the beverage's optimal CO2 concentration and temperature. The filling machines operate at high speeds, capable of processing thousands of containers per minute. For PET and glass bottles, filling is done using gravity-based or counter-pressure filling systems. In a counter-pressure system, the bottle is first pressurized with CO2 before the Pepsi is introduced. This prevents foaming and excessive carbonation loss during filling. The precise amount of liquid is dispensed into each bottle, with sensors ensuring that no underfilled or overfilled bottles proceed down the production line. Aluminum cans require a slightly different approach. Since they are more prone to CO2 loss due to their wide openings, the filling nozzles are designed to minimize turbulence as the liquid enters. The cans are quickly filled and then topped with a small injection of nitrogen gas to prevent oxidation before being sealed. Now that the containers are filled with carbonated Pepsi, the next critical step is sealing. This process must be done immediately after filling to prevent carbonation loss and contamination. For plastic and glass bottles, this involves capping. Screw-on plastic caps are applied to PET bottles using high-speed rotary capping machines, which tighten each cap with precise torque to ensure a secure seal. Glass bottles, often used for premium or international markets, are sealed with either metal crown caps or twist-off caps, depending on the region. Aluminum cans are sealed using a double seaming process. A lid, which contains an integrated pull tab, is placed on top of the can and then mechanically crimped around the rim. This creates an airtight seal that locks in carbonation and prevents leakage. With all the containers now sealed, they move on to the quality control phase. At this stage, random samples are pulled from the production line and tested for multiple factors, including fill level, carbonation retention, pressure stability, and contamination. Advanced X-ray and laser scanning systems inspect each bottle and can to ensure that there are no foreign particles, dents, or defects in the packaging. Any defective units are immediately rejected and removed from the batch. Once the beverages pass quality control, the containers proceed to labeling. Each bottle and can receives a label that includes branding, nutritional information, ingredient lists, and regulatory compliance markings. PET bottles have labels applied using heat shrink or pressure-sensitive label machines, while aluminum cans typically have their designs pre-printed onto the metal surface. After labeling, the bottles and cans are grouped into multi-packs for retail distribution. This process involves bundling them into various configurations, such as 6-packs, 12-packs, or full cases. Plastic shrink wrap, cardboard trays, or molded carrying handles are used to secure the multi-packs for easy transportation. The completed packs are then stacked onto pallets in an organized manner and wrapped in stretch film to stabilize them for shipping. Now it's time for one of the most logistically challenging aspects of Pepsi production: distribution. The pallets of finished Pepsi products are moved to temperature-controlled warehouses where they are stored before being shipped to retailers, grocery stores, vending machines, and restaurants. Since Pepsi is produced in enormous quantities to meet global demand, distribution logistics must be precisely managed to ensure that every store and vendor receives fresh products. Pepsi's supply chain is a highly coordinated operation involving fleet management, refrigerated storage, and just-in-time delivery systems. Large distribution centers act as hubs where shipments are sorted based on region and customer demand. Trucks, rail transport, and even cargo ships are used to move massive volumes of Pepsi across countries and continents. Once the products arrive at their final destinations, they are placed in cold storage or directly onto store shelves. In grocery stores and supermarkets, Pepsi is often stored in temperature-controlled sections to maintain freshness. Restaurants and fast food chains receive large volumes of Pepsi in bulk containers, which are connected to soda fountains for on-demand dispensing. Throughout this entire process, PepsiCo maintains strict inventory tracking and quality assurance programs. Each batch of Pepsi is assigned a unique tracking code, allowing the company to trace products back to their production date, location, and ingredient sources. This ensures that in the event of a recall or quality issue, affected products can be quickly identified and removed from circulation. With the Pepsi bottles and cans now filled, sealed, labeled, and packed for distribution, one of the final but most crucial aspects of the manufacturing process is ensuring product consistency, longevity, and consumer satisfaction. Maintaining Pepsi's signature taste and quality across millions of bottles and cans requires an advanced system of quality control, storage optimization, and packaging innovation. Every aspect, from the shelf life of the product to the materials used in packaging, plays a role in ensuring that each Pepsi delivered to a consumer is as fresh and enjoyable as the last. The first key factor in Pepsi's shelf life and consistency is its ability to retain carbonation over time. Carbonation, which gives Pepsi its signature fizziness, is created by dissolving carbon dioxide into the liquid under high pressure. The challenge is ensuring that this CO2 remains trapped within the beverage from the moment it is bottled until it is opened by the consumer. To maintain carbonation, Pepsi uses specially designed bottles and cans that act as airtight barriers, preventing CO2 from escaping. Plastic bottles made from polyethylene terephthalate are engineered with multiple layers that slow down gas diffusion, preventing CO2 from seeping out over time. The thickness and structure of PET bottles are carefully optimized to balance durability with weight, ensuring that the bottles are strong enough to retain carbonation while remaining lightweight for transportation. Aluminum cans provide an even better barrier against gas loss. Their completely sealed structure ensures that no CO2 escapes, preserving the drink's fizziness for extended periods. Additionally, a protective food-grade lining inside each can prevent any reaction between the metal and the beverage, which could otherwise affect flavor. Glass bottles, often used for premium markets or limited edition versions of Pepsi, offer the best gas retention of all packaging types. Glass is completely impermeable, meaning that Pepsi stored in glass bottles maintains its carbonation for the longest period. However, glass is heavier and more fragile than plastic or aluminum, making it less practical for mass production and distribution. Another critical factor in product longevity is preventing oxidation. Exposure to oxygen can alter the taste of Pepsi, causing it to become flat and develop off flavors over time. To counter this, PepsiCo employs nitrogen dosing in certain packaging lines. This process involves injecting a small amount of nitrogen gas into PET bottles just before sealing. The nitrogen displaces any residual oxygen inside the bottle, reducing the risk of oxidation while also adding structural rigidity to the bottle, preventing it from collapsing under vacuum pressure. Beyond carbonation and oxidation control, preservatives also play a role in maintaining Pepsi's freshness. While the beverage's acidity and carbonation naturally inhibit microbial growth, additional preservatives such as sodium benzoate are included to extend shelf life further. These preservatives prevent mold, yeast, and bacterial growth, ensuring that Pepsi remains safe for consumption for months or even years after production. Now that the beverage's stability is secured, it must be stored and transported under optimal conditions. Pepsi is highly sensitive to temperature fluctuations, which can affect carbonation retention and overall flavor. As a result, warehouses, distribution centers, and retail storage areas are kept within a controlled temperature range to prevent heat exposure. Excessive heat can accelerate CO2 loss in plastic bottles and increase oxidation reactions, leading to a flatter, less refreshing drink. To counteract this, refrigerated warehouses are used in regions where high temperatures could compromise product quality. During transportation, trucks equipped with climate control ensure that Pepsi is not exposed to extreme heat or direct sunlight, both of which could degrade the beverage. Another major factor that affects Pepsi's taste consistency is the impact of light exposure. Ultraviolet light can break down some of the organic compounds in Pepsi's flavoring, leading to unwanted taste changes. This is why Pepsi bottles, particularly those made from PET, are designed with tinted or opaque plastic to reduce UV penetration. Aluminum cans and glass bottles naturally provide complete light protection, further ensuring product stability. Once Pepsi reaches its final retail destinations, whether in grocery stores, vending machines, or fast food chains, it is crucial that storage guidelines continue to be followed. Retailers are instructed to keep Pepsi stock rotated, ensuring that older products are sold first and newer shipments are stored properly. This helps maintain product freshness for consumers while preventing expired stock from sitting on shelves. Fast food chains and restaurants that serve Pepsi from soda fountains have additional steps to ensure taste consistency. Instead of pre-packaged bottles and cans, Pepsi is delivered to these locations in large pressurized syrup containers known as bag-in-box systems. These containers hold concentrated Pepsi syrup, which is mixed with carbonated water on demand through specialized dispensing machines. The bag-in-box system allows for efficient storage and prevents waste, as restaurants can control the syrup-to-water ratio for optimal taste. These systems are regularly maintained, with filters and carbonation settings adjusted to match the ideal flavor profile. Additionally, PepsiCo provides restaurants with quality control tools to measure CO2 levels and syrup concentration, ensuring that every poured glass tastes as good as a bottled Pepsi. With all these measures in place, Pepsi is now fully ready for consumers to enjoy. But beyond the immediate production and distribution, PepsiCo continually invests in research and development to improve manufacturing efficiency, sustainability, and packaging innovations. One of the company's most significant focuses in recent years has been reducing the environmental impact of its packaging. PepsiCo has made major advancements in recyclable PET bottle technology, developing bottles that contain post-consumer recycled plastic to cut down on waste. Additionally, the company has experimented with plant-based PET alternatives that reduce reliance on petroleum-based plastics. Aluminum cans have also been a major target for sustainability improvements. Since aluminum is highly recyclable, PepsiCo has worked to increase the amount of recycled aluminum used in can production. The company encourages consumers to participate in recycling programs, ensuring that cans are properly collected and reused. In some markets, PepsiCo has even introduced refillable glass bottle programs, allowing consumers to return used bottles for sanitation and reuse, significantly cutting down on single-use waste. Further technological advancements in bottling machinery have also improved efficiency in the production process. The Coca-Cola process begins long before the beverage reaches the consumer, starting with the sourcing of raw ingredients and the preparation of the secret formula. The recipe is one of the most closely guarded trade secrets in the world, known only to a select few individuals. However, while the exact proportions of the ingredients remain undisclosed, the general components are well understood. Carbonated water, high fructose corn syrup or sugar, caramel color, phosphoric acid, natural flavors, and caffeine. The first step in manufacturing Coca-Cola is obtaining and preparing these ingredients. Water is the most important component, making up the majority of the drink. It must be purified to remove any impurities before being used in the production process. This is done through a series of filtration and purification steps, including sand filtration, carbon filtration, and reverse osmosis. These processes remove sediments, chlorine, organic compounds, and any potential contaminants, ensuring that only the purest water is used in Coca-Cola's production. The water purification process is vital because any variation in water quality could affect the final taste of the beverage. Once the water has been purified, it is ready to be mixed with the other ingredients. The syrup preparation process begins in a separate area of the factory, where high fructose corn syrup or sugar is combined with caramel coloring, phosphoric acid, and natural flavors. The caramel color gives Coca-Cola its distinct deep brown appearance, while phosphoric acid contributes to its tartness. The natural flavors used in Coca-Cola are a closely guarded secret, but they are essential in creating the beverage's unique taste. The caffeine is also added during this stage, ensuring that the drink maintains its signature stimulating effect. After the syrup is prepared, it must be carefully measured and mixed with the purified water. This is done through an automated batching system that ensures the precise ratio of syrup to water. The mixture is then subjected to a process called de-aeration, which removes any trapped air that could affect carbonation and shelf stability. This step is crucial because any excess air can lead to inconsistencies in taste and texture. Next, the mixture undergoes carbonation, one of the most important steps in the manufacturing process. Carbonation is achieved by injecting carbon dioxide into the liquid under controlled pressure and temperature conditions. The level of carbonation must be carefully calibrated to ensure that Coca-Cola has the right amount of fizziness. The CO2 used in this process is food grade and purified to remove any impurities. This step requires precision because too much or too little carbonation can alter the drink's mouthfeel and overall experience. Once the beverage has been carbonated, it is ready for bottling and packaging. However, before this can happen, the bottles or cans must be thoroughly cleaned and sterilized. This is a critical step in ensuring product safety and hygiene. Factories typically use high-pressure water jets and a sterilizing solution to clean the bottles before they are filled. Any residue or foreign particles in the bottles could compromise the quality of the drink, so this cleaning process is carefully monitored. With the bottles prepared, the filling process begins. The carbonated Coca-Cola mixture is dispensed into bottles or cans using high-speed filling machines that operate with incredible precision. The filling process must be conducted under controlled conditions to prevent foaming and loss of carbonation. The machines are designed to fill each container with the exact volume of liquid, ensuring consistency across all units. The filled bottles are then capped immediately to preserve carbonation and freshness. After capping, the bottles go through a labeling and coding process. Labels are applied to the bottles using automated machinery, and each bottle is imprinted with a date code to indicate its production date and best before date. This coding process helps with inventory management and quality control, allowing factories to track each batch of production. The labels are carefully inspected to ensure they are applied correctly, as any misaligned or missing labels can lead to packaging errors. Once labeled, the bottles move through a quality control checkpoint where they are inspected for any defects. This inspection process involves both human oversight and automated systems. High-speed cameras and sensors check for issues such as incorrect fill levels, damaged bottles, or improperly sealed caps. If any defects are detected, the affected bottles are removed from the production line to prevent them from reaching consumers. The quality control stage is one of the most critical aspects of Coca-Cola manufacturing, as it ensures that only products meeting the highest standards make it to market. After passing inspection, the bottles are packed into crates or cartons for distribution. The packaging process is fully automated, with robotic arms and conveyor belts handling the movement of products. The bottles are grouped into packs, shrink-wrapped for protection, and stacked onto pallets for transportation. The factory's logistics system ensures that the packaged products are efficiently stored and transported to distribution centers, where they are shipped to retailers, restaurants, and vending machines. The manufacturing process of Coca-Cola is designed for efficiency and precision at every stage. Factories are equipped with advanced technology and highly automated systems to ensure that production runs smoothly and consistently. Every step, from ingredient preparation to final packaging, is carefully monitored to maintain quality and safety standards. The final step before distribution involves conducting random sampling and additional quality control tests to ensure that the beverage meets Coca-Cola's strict standards. Samples are taken from each batch and tested in a laboratory for factors such as acidity, carbonation levels, and taste consistency. These tests help verify that the product remains true to Coca-Cola's signature flavor profile. If any deviations are found, adjustments are made to maintain quality. Coca-Cola factories operate around the clock, producing millions of bottles per day to meet global demand. The entire process is streamlined for maximum efficiency, ensuring that consumers receive fresh, high-quality beverages every time they purchase a bottle of Coca-Cola. The company places a strong emphasis on sustainability, incorporating water recycling and energy-efficient practices into its production processes. Water conservation efforts, CO2 recapture systems, and waste reduction initiatives help minimize the environmental impact of Coca-Cola manufacturing. Once the filled and capped bottles of Coca-Cola have undergone the initial stages of quality control, they move to an advanced inspection phase, where both automated systems and human supervisors ensure that every bottle meets the company's stringent standards. At this point, the bottles or cans are carefully checked for fill level accuracy, seal integrity, and carbonation retention. Sophisticated machines equipped with high-speed cameras analyze thousands of bottles per minute, identifying any anomalies such as underfilled or overfilled bottles, leaks, or incorrectly applied caps. If a defect is detected, the bottle is automatically removed from the production line and sent to a separate area for further evaluation. In cases where minor adjustments can be made, such as reapplying a cap that wasn't sealed properly, corrective measures are taken before the bottle is returned to the production process. However, if the defect compromises the quality of the beverage, the bottle is discarded to maintain consistency and uphold Coca-Cola's reputation for high-quality products. Parallel to this, another critical process occurs in the factory: batch testing. Randomly selected bottles from each production run are taken to an on-site laboratory, where they undergo extensive chemical and sensory analysis. Laboratory technicians assess factors such as pH levels, sugar concentration, carbonation levels, and overall taste profile to confirm that the beverage aligns perfectly with Coca-Cola's standardized formulation. Any deviation from the expected specifications results in a thorough investigation, ensuring that the issue is promptly identified and corrected. Once the bottles pass quality checks, they move on to secondary packaging. Coca-Cola is typically sold in various formats, including individual bottles, 6-packs, 12-packs, and even bulk cartons containing dozens of bottles or cans. High-speed automated packaging machines arrange the bottles into their designated configurations, wrapping them in plastic film or placing them into cardboard carriers. These machines operate with incredible precision, ensuring that every package is neatly assembled and securely sealed. At this stage, sustainability efforts come into play. Coca-Cola has invested heavily in reducing plastic waste and optimizing its packaging materials. Many of the plastic bottles used in Coca-Cola production are made from recycled PET, and the company continuously works toward increasing the percentage of recycled content in its packaging. In some regions, Coca-Cola also uses plant-based plastic materials to further minimize its environmental impact. The secondary packaging materials, such as cardboard cartons, are often sourced from recycled paper products, aligning with Coca-Cola's commitment to sustainability. Once packaged, the finished products are transported through a network of conveyor belts to a distribution staging area within the factory. Here, robotic palletizers stack the products onto pallets, organizing them efficiently for shipping. These robots use advanced algorithms to optimize space utilization, ensuring that the maximum number of products can be transported with minimal waste. The palletized products are then wrapped in protective plastic film to keep them secure during transit. The next step in the Coca-Cola manufacturing process is logistics and distribution. The company operates a vast global supply chain, with each factory producing beverages that are distributed to local and regional markets. Trucks, trains, and even cargo ships transport Coca-Cola products to distribution centers, warehouses, and retail locations around the world. The logistical network is meticulously planned to minimize transportation costs and reduce the carbon footprint of product distribution. Before shipping, warehouse personnel use barcode scanning systems and inventory management software to track every pallet of Coca-Cola. Each unit is assigned a unique barcode that corresponds to its production date, batch number, and destination. This tracking system enables the company to efficiently manage stock levels and quickly address any issues that may arise, such as recalls or shipment delays. In many cases, Coca-Cola products are delivered directly to retailers, including supermarkets, convenience stores, and vending machine operators. The company's extensive distribution network ensures that consumers can access fresh Coca-Cola virtually anywhere in the world. To maintain the freshness of the beverage, Coca-Cola implements a strict first-in, first-out inventory system, which prioritizes the sale of older stock before newer stock reaches store shelves. While Coca-Cola's distribution network ensures that the beverage reaches consumers efficiently, the manufacturing process doesn't end once the product leaves the factory. Coca-Cola factories also focus on sustainability initiatives aimed at reducing environmental impact. Water conservation is a major priority, given that water is the primary ingredient in Coca-Cola. Factories implement advanced water recycling systems, allowing them to treat and reuse water for non-product related processes such as equipment cleaning and cooling. Energy efficiency is another key focus. Many Coca-Cola plants utilize renewable energy sources such as solar and wind power to offset electricity consumption. The company also invests in energy-efficient machinery, reducing the overall carbon footprint of its manufacturing operations. Additionally, Coca-Cola works with local communities to support environmental sustainability initiatives such as reforestation programs and water replenishment projects. Another important aspect of Coca-Cola's manufacturing process is its adherence to strict food safety regulations. Factories comply with global food safety standards, including the hazard analysis and critical control point system, which identifies and mitigates potential risks in food production. Employees undergo regular training on hygiene protocols, and strict sanitation measures are enforced throughout the facility. Production areas are regularly disinfected, and equipment is thoroughly cleaned after each batch to prevent cross-contamination. Coca-Cola also invests in research and development to continuously refine its production processes. Scientists and engineers work to optimize ingredient formulations, improve packaging materials, and enhance the efficiency of manufacturing operations. Innovation plays a crucial role in Coca-Cola's success, allowing the company to adapt to changing consumer preferences and market demands. For example, in response to growing health-conscious trends, Coca-Cola has introduced reduced sugar and zero sugar variants, all of which undergo the same rigorous manufacturing process as the original formula. One of the most impressive aspects of Coca-Cola's manufacturing process is its ability to maintain consistency across different regions. Regardless of where Coca-Cola is produced, whether in North America, Europe, Asia, or Africa, the taste and quality of the beverage remain the same. This consistency is achieved through strict adherence to Coca-Cola's global manufacturing standards, which dictate precise ingredient ratios, quality control measures, and production techniques. Each factory is regularly audited to ensure compliance with these standards, ensuring that consumers receive the same great-tasting Coca-Cola wherever they are in the world. Despite the high level of automation in Coca-Cola factories, human oversight remains essential. Factory workers play a crucial role in monitoring production lines, troubleshooting issues, and ensuring that operations run smoothly. From syrup blending technicians to quality control inspectors, every employee contributes to the success of the manufacturing process. Safety is also a top priority, with factories implementing comprehensive occupational health and safety programs to protect workers from potential hazards. The production of Coca-Cola is a complex and finely tuned process that extends beyond simply mixing ingredients and filling bottles. It involves numerous specialized stages that ensure the beverage maintains its signature taste, quality, and safety. As the bottled or canned Coca-Cola moves through the factory, the focus remains on maintaining efficiency, consistency, and sustainability. One of the key elements of Coca-Cola's production process is the careful management of carbonation. The carbon dioxide used to carbonate the beverage is sourced from food-grade suppliers and must meet strict purity standards. Maintaining consistent carbonation levels is critical because it affects the drink's texture, mouthfeel, and overall sensory experience. Carbonation is carefully controlled during the filling process to ensure that the right amount of CO2 is dissolved into the liquid. If the pressure or temperature is not properly maintained, the carbonation can dissipate too quickly, leading to a flat-tasting beverage. To prevent this, Coca-Cola factories use pressurized filling machines that ensure minimal CO2 loss as the beverage is transferred into bottles or cans. Once filled and capped, Coca-Cola bottles move through a final stage of quality assurance before they are packed and prepared for shipment. Each bottle is subjected to a high-speed laser inspection system that verifies the presence of the cap, ensures proper sealing, and checks for any defects in the glass or plastic. These laser inspection systems can detect even microscopic irregularities that might not be visible to the human eye, helping prevent faulty products from reaching the market. One of the most crucial aspects of Coca-Cola's manufacturing process is ensuring uniformity across all production facilities worldwide. To achieve this, the company employs a centralized quality control system that enforces strict guidelines for ingredient sourcing, syrup production, water purification, and carbonation. Each factory follows a standardized protocol, and periodic audits are conducted to verify compliance. This rigorous attention to detail ensures that a bottle of Coca-Cola produced in the United States tastes identical to one manufactured in Japan, South Africa, or Brazil. While consistency is a priority, Coca-Cola also tailors its formulation slightly to accommodate regional preferences and regulatory requirements. In some countries, the beverage is sweetened with high fructose corn syrup, while in others, cane sugar is used. Additionally, the amount of caffeine in the beverage may vary slightly depending on local guidelines. Despite these subtle differences, the core flavor profile remains the same, thanks to the precise blending of the secret formula. After passing through final quality control checks, Coca-Cola bottles and cans are directed toward packaging and palletizing. At this stage, packaging automation plays a key role in optimizing efficiency. Modern Coca-Cola factories use robotic arms and conveyor systems to sort, pack, and shrink wrap the products into multi-packs, cases, or crates. These machines work at incredible speeds, sometimes processing thousands of bottles per minute. Sustainability efforts are heavily integrated into the packaging process. Coca-Cola has made significant strides in reducing its environmental impact by using lightweight packaging materials, increasing the use of recycled plastics, and investing in refillable bottle programs. Many Coca-Cola factories have adopted a closed-loop recycling system in which used plastic bottles are collected, cleaned, and reprocessed into new bottles. This reduces reliance on virgin plastic and minimizes waste. Once the Coca-Cola products are packed and palletized, they are moved to the warehouse storage area within the factory. This area is carefully temperature controlled to preserve the beverage's freshness and carbonation levels. Coca-Cola's warehouse management system tracks each pallet's movement, ensuring that products are stored efficiently and dispatched in a timely manner. From the warehouse, Coca-Cola products are distributed through a highly organized logistics network. The company utilizes a combination of trucks, rail transport, and shipping containers to move its products from manufacturing facilities to regional distribution centers. These centers act as hubs that supply retailers, restaurants, and vending machines with fresh stock. Coca-Cola's logistics team uses advanced forecasting software to predict demand and optimize delivery routes, reducing fuel consumption and improving efficiency. Once Coca-Cola reaches retail locations, the company's work is not finished. Coca-Cola employs a global network of merchandising teams that ensure products are displayed prominently in stores, kept at the right temperature, and stocked in vending machines and coolers. These teams also monitor product rotation, ensuring that older stock is sold first to maintain freshness. Another key element in Coca-Cola's manufacturing and distribution process is its commitment to reducing water usage. Water stewardship is a major initiative for Coca-Cola, as the company relies heavily on water as its primary ingredient. Many Coca-Cola plants have implemented state-of-the-art water reclamation systems that allow them to recycle and reuse water in non-product applications such as equipment cooling and bottle washing. These efforts help minimize water waste and ensure responsible water management. In addition to water conservation, Coca-Cola has also invested in reducing its overall carbon footprint. Many of its manufacturing plants have adopted energy-efficient technologies, including solar panels, wind turbines, and advanced heat recovery systems. These measures help Coca-Cola decrease its reliance on fossil fuels and reduce greenhouse gas emissions. The company has also transitioned many of its delivery trucks to hybrid or electric models to further lower its environmental impact. While Coca-Cola's manufacturing process is highly automated, it still requires a skilled workforce to oversee operations. Factory employees play a crucial role in maintaining equipment, monitoring production lines, and conducting quality checks. They receive extensive training to ensure they understand food safety protocols, machinery operation, and emergency procedures. Coca-Cola places a strong emphasis on worker safety, implementing strict guidelines to protect employees from potential hazards associated with high-speed machinery and industrial production environments. The level of precision required to produce Coca-Cola at such a massive scale is truly remarkable. Every ingredient, every machine, and every worker plays a vital role in ensuring that millions of bottles of Coca-Cola can be produced and distributed each day without compromising quality. The company's ability to manufacture its beverage with such consistency across different regions is a testament to the effectiveness of its standardized processes and advanced technology. Coca-Cola's manufacturing journey doesn't end once the product reaches consumers. The company continues to innovate, finding new ways to improve its production methods, reduce its environmental impact, and adapt to changing consumer preferences. Recent innovations include the development of plant-based plastic bottles, the introduction of lower-calorie and sugar-free alternatives, and improvements in energy-efficient bottling techniques. As Coca-Cola's manufacturing process continues beyond the bottling and packaging stages, the company remains focused on optimizing efficiency, reducing waste, and ensuring that every bottle that reaches the consumer meets its high standards. With millions of bottles and cans produced daily in factories around the world, Coca-Cola relies on a seamless integration of automated systems, rigorous quality control, and strategic logistics to maintain its position as one of the most recognizable beverages on the planet. One of the most important aspects of Coca-Cola's production process is its supply chain management. The company sources its ingredients from a global network of suppliers, ensuring that its factories receive high-quality raw materials consistently. The supply chain involves the coordinated movement of sugar or high-fructose corn syrup, caffeine, caramel coloring, phosphoric acid, and natural flavorings, all of which must be stored under precise conditions to maintain their integrity. The syrup used to create Coca-Cola is produced in specialized facilities known as concentrate plants. These plants manufacture the highly concentrated base syrup, which is then shipped to bottling facilities worldwide, where it is mixed with purified water and carbonated before packaging. Once the concentrate reaches the bottling plant, it is diluted with purified water following Coca-Cola's standardized formulation. The water undergoes extensive treatment to remove any impurities, ensuring that the final beverage maintains the same taste, regardless of where it is produced. The carbonation process is carefully monitored, as even a slight variation in CO2 levels can affect the drink's mouthfeel and effervescence. Coca-Cola's research and development teams continuously refine the carbonation techniques to ensure the perfect balance of bubbles in every sip. With the beverage ready for packaging, Coca-Cola utilizes a diverse range of bottling formats to cater to different consumer preferences. The company produces its beverages in glass bottles, aluminum cans, and PET plastic bottles, each with its own specific manufacturing process. Glass bottles, for example, require a specialized filling line that ensures the bottles are sterilized before filling, capped securely, and transported safely. PET bottles undergo a process called blow molding, in which small preforms of plastic are heated and expanded into the shape of a full-sized bottle using high-pressure air. This method allows Coca-Cola to produce lightweight, durable bottles that are both cost-effective and recyclable. As the bottles and cans move through the high-speed production lines, they are continuously monitored by automated inspection systems. These systems use infrared sensors, X-ray technology, and high-speed cameras to detect any irregularities in fill levels, cap placement, and structural integrity. Bottles that do not meet Coca-Cola's quality standards are automatically removed from the line and discarded or recycled. This attention to detail ensures that only perfect products reach consumers. After being filled, capped, and labeled, Coca-Cola products are assembled into multi-packs or crates for easier handling and distribution. The packaging process is designed for maximum efficiency with robotic arms swiftly arranging the bottles into their respective cases. Sustainability remains a key focus during this stage, with Coca-Cola implementing measures to reduce plastic waste by using lightweight packaging materials and increasing the use of recycled content. Many Coca-Cola plants have adopted a closed-loop recycling system in which post-consumer PET bottles are collected, cleaned, and transformed into new bottles. This initiative significantly reduces the company's reliance on virgin plastics and helps minimize environmental impact. Once packaged, the products are transported to warehouse storage areas, where they are organized based on expiration dates and distribution routes. Coca-Cola follows a strict first in, first out inventory system to ensure that older stock is shipped out before newer stock, preventing waste and maintaining freshness. The company's advanced inventory management system tracks every case, ensuring that retailers receive the right products at the right time. From the warehouse, Coca-Cola products embark on their journey to retailers, supermarkets, vending machines, and restaurants. The company's logistics team meticulously plans transportation routes to optimize delivery efficiency and reduce fuel consumption. Coca-Cola operates a fleet of delivery trucks, many of which are equipped with refrigeration units to keep beverages cool during transit. In some regions, Coca-Cola has introduced electric delivery trucks to further minimize its carbon footprint. While Coca-Cola's production process is largely automated, human oversight remains essential at every stage. Factory employees play a critical role in ensuring that operations run smoothly, troubleshooting machinery issues, and maintaining stringent hygiene standards. Workers undergo regular training to stay up to date with food safety protocols, equipment operation, and emergency response procedures. The company prioritizes worker safety, implementing strict guidelines to protect employees from potential hazards associated with high-speed production lines and industrial equipment. Coca-Cola's commitment to sustainability extends beyond its factories and supply chain. The company actively invests in water conservation projects, renewable energy initiatives, and recycling programs to reduce its overall environmental impact. In many regions, Coca-Cola collaborates with local communities to replenish water sources and support biodiversity conservation efforts. For every liter of water used in its production process, Coca-Cola works to return an equivalent amount to the environment through water stewardship initiatives. Another area of continuous improvement within Coca-Cola's manufacturing process is the development of innovative beverage formulations. In response to evolving consumer preferences, Coca-Cola has expanded its product portfolio to include sugar-free and low-calorie alternatives. The production of these variations follows a similar process to the original formula, with slight adjustments made to accommodate different sweeteners and flavor profiles. The introduction of Coca-Cola Zero Sugar and Diet Coke has required modifications to syrup formulation and taste testing procedures to ensure that these alternatives maintain the same crisp, refreshing experience as the classic version. Beyond traditional retail, Coca-Cola is also distributed through vending machines and fountain dispensers. The production of Coca-Cola syrup for fountain machines follows a slightly different process, as the syrup is shipped in concentrated form to restaurants and fast food chains, where it is mixed with carbonated water on site. This method allows for efficient storage and reduces packaging waste. The process begins with water, which forms the base of cherry Coca-Cola. It's not just any water that can be used. It must be highly purified to ensure no off-tastes or impurities interfere with the final product. Upon arrival at the factory, water undergoes a multi-step purification process. First, it is passed through large sand filters to remove visible debris and particulate matter. Next, it moves through activated carbon filters, which strip out chlorine and other organic compounds that could affect the drink's flavor. This step is crucial in ensuring a neutral tasting base. After this, reverse osmosis or microfiltration is employed to remove microscopic contaminants, bacteria, and dissolved minerals. This purified water is continuously tested for pH balance and purity before being approved for use. Now, it's time to introduce the sweeteners, which are responsible for cherry Coca-Cola's characteristic sweetness. The type of sweetener used depends on the region. In North America, high fructose corn syrup is the primary choice due to its affordability and efficient blending properties. In other regions, sucrose from sugarcane or sugar beets is used. HFCS is produced through an enzymatic conversion process that transforms cornstarch into glucose and then into fructose, creating a highly soluble and sweet liquid. The syrup, or sucrose, is delivered in tanker trucks and stored in large stainless steel silos within the factory. Before use, the sweetener is filtered and preheated to ensure it integrates seamlessly with the rest of the ingredients. The next essential ingredient is phosphoric acid, which gives cherry Coca-Cola its slight tang and acts as a preservative. Phosphoric acid is sourced from phosphate rock, which is treated with sulfuric acid to produce a food-grade acid that can be used in soft drinks. This ingredient arrives at the factory in concentrated liquid form and is stored in specialized tanks to prevent contamination. Precision is key when adding phosphoric acid. Even a slight variation in concentration can alter the drink's flavor balance, making it too tart or too flat. Caffeine, another critical component, is added to provide the beverage's stimulating effect. The caffeine used in cherry Coca-Cola is either extracted from coffee beans and tea leaves or synthesized in laboratories to maintain consistency. It arrives in powdered form and must be carefully measured before being dissolved into the syrup mixture. One of the most recognizable aspects of cherry Coca-Cola is its deep brown color, which is achieved using caramel color. Caramel color is made by heating sugar compounds with acids or alkalis, creating a complex mixture of caramelized sugars that provide both color and subtle bitter notes that complement the drink's sweetness. Caramel color must be carefully controlled for shade consistency, ensuring that every batch of cherry Coca-Cola has the same appearance. Now, it's time to add the proprietary natural flavors that define Coca-Cola's unmistakable taste. These flavors, known internally as Merchandise 7X, are a carefully guarded secret, containing a mix of citrus oils, spices, and herbal extracts. The precise blend is known only to a handful of people within the Coca-Cola company. These concentrated flavoring agents are added in precise amounts, ensuring the signature cola taste remains identical across all global production sites. But what truly differentiates cherry Coca-Cola from its classic counterpart is the cherry flavoring. This is created using natural cherry extracts or synthetic cherry compounds, depending on local regulations and supply chain availability. Natural cherry extracts are obtained through cold pressing ripe cherries to capture their essence, while synthetic cherry flavors replicate the fruity, slightly tart taste using chemical compounds such as benzaldehyde. The cherry flavor must be added in a carefully measured amount to create a perfect balance with the cola notes without overpowering them. Once all the ingredients have been sourced, purified, and prepared, it's time for the next step, creating the concentrated syrup. In a dedicated syrup production area of the factory, large stainless steel mixing tanks equipped with powerful agitators are used to blend the ingredients into a homogeneous mixture. The process starts by heating the purified water slightly to improve ingredient solubility. The sweetener, whether HFCS or sucrose, is then gradually introduced while the mixture is stirred continuously to prevent crystallization. Next, the phosphoric acid is added, providing cherry Coca-Cola with its signature tangy undertone. Because phosphoric acid is highly concentrated, automated dosing systems are used to ensure precise measurement, preventing any deviations in taste. Following this, the caffeine is dissolved in a small amount of warm water before being incorporated into the syrup, ensuring even distribution throughout the mixture. The natural flavors, including the Merchandise 7X blend and cherry flavoring, are then carefully added. These flavor components are typically pre-mixed into an emulsified solution to ensure they disperse evenly throughout the syrup. This step is crucial, as any inconsistencies in flavor distribution can lead to variations in taste between different production batches. Finally, the caramel color is introduced, giving cherry Coca-Cola its signature appearance. Once all the ingredients are combined, the syrup undergoes a multi-stage filtration process to remove any undissolved particles. This is typically done using fine mesh filters or centrifugal separation methods, ensuring that the syrup is smooth and free from any impurities. After filtration, the syrup is transferred to holding tanks, where it is kept under controlled conditions before being sent to the bottling stage. Throughout the syrup production process, quality control plays a vital role. Factory workers take samples from each batch and conduct tests to measure sweetness levels, acidity, and overall flavor consistency. Sensory panels, trained employees who specialize in taste testing, evaluate the syrup to ensure it matches the established cherry Coca-Cola flavor profile. If any discrepancies are detected, adjustments are made before the syrup is approved for bottling. With the syrup now fully prepared, the next step is dilution, carbonation, and bottling. This is where the concentrated syrup is combined with carbonated water and packaged into cans and bottles for distribution worldwide. But before we get to that, the syrup must first be transported to the filling stations in a highly controlled manner. The next phase of production ensures that the correct syrup-to-water ratio is maintained and that the carbonation process delivers the signature effervescence that makes cherry Coca-Cola such a refreshing drink. Now that the syrup is ready, it's time to move on to the next critical stage, blending the syrup with carbonated water and ensuring that the correct levels of fizziness, taste, and consistency are achieved in every bottle and can. This process is where cherry Coca-Cola transforms from a concentrated mixture into the refreshing, bubbly beverage that millions of consumers enjoy. Now that the concentrated cherry Coca-Cola syrup is fully prepared and stored under controlled conditions, it's time to move on to the next crucial step in the manufacturing process: blending the syrup with carbonated water and ensuring the perfect level of fizziness. This stage is where cherry Coca-Cola takes its final form, transforming from a concentrated mixture into the refreshing, bubbly beverage that millions of people enjoy. The precision involved in this step is critical because even slight inconsistencies in carbonation or syrup dilution can result in an off-tasting product. The process begins with the careful transportation of the concentrated syrup to the filling stations. To prevent contamination and maintain consistency, the syrup is pumped through stainless steel pipes from the storage tanks to a specialized mixing unit known as a proportioner. The proportioner is one of the most vital machines in the entire production line, as it precisely controls the ratio of syrup to water. Cherry Coca-Cola's signature taste depends on the exact balance of ingredients, and any deviation in the syrup to water ratio could result in an overly sweet or weak-tasting beverage. The standard ratio for Coca-Cola products is approximately 1 part syrup to 5 parts carbonated water, but this can vary slightly depending on factors such as temperature and altitude, which can affect carbonation retention. Before the syrup and water are combined, the water must undergo a final round of purification to ensure absolute consistency. Even though the water has already been filtered and purified at the beginning of the process, additional treatment steps are performed just before carbonation. The water is passed through activated carbon filters once more to remove any remaining traces of chlorine or organic matter. Then it is chilled to a precise temperature, usually around 1 to 3 degrees Celsius. Chilling the water at this stage is essential because cold liquid absorbs carbon dioxide more efficiently, which results in finer and longer-lasting bubbles in the final product. Now comes the most intricate step: carbonation. The carbonation process is what gives cherry Coca-Cola its signature fizz and enhances the overall drinking experience. Carbon dioxide gas is injected into the chilled water under high pressure using specialized carbonation tanks. These tanks are equipped with fine diffusion plates that allow the gas to dissolve evenly into the liquid, ensuring consistent carbonation levels throughout the entire batch. The CO2 used in this process must be of food-grade quality, free from impurities that could alter the beverage's taste. To maintain the ideal carbonation level, the process is carefully controlled using high-precision sensors that monitor temperature, pressure, and CO2 concentration in real time. Once the water is fully carbonated, it is immediately mixed with the concentrated cherry Coca-Cola syrup inside the proportioner. This must be done swiftly to prevent any loss of carbonation. The high-speed blending process ensures that the syrup and carbonated water mix thoroughly without causing excessive foaming, which could lead to product loss. As soon as the mixture is complete, the freshly carbonated cherry Coca-Cola is sent directly to the filling lines for packaging. However, this must be done under strictly controlled conditions to maintain carbonation and prevent oxidation, which could negatively affect the beverage's taste and shelf life. The next step is the bottling and canning process, where the freshly mixed cherry Coca-Cola is transferred into its final packaging. This stage of production requires highly specialized machinery that can fill thousands of bottles and cans per minute while maintaining product integrity. The bottling and canning lines operate at incredible speeds, and every detail, from the fill level to the sealing process, must be executed with extreme precision. The filling process begins with the preparation of the containers. Whether the product is being packaged in aluminum cans, plastic PET bottles, or glass bottles, each type of packaging undergoes a thorough cleaning and sterilization process before being filled. In the case of aluminum cans, they arrive at the factory in bulk and are depalletized before being sent through an inverted high-pressure air rinsing system that removes any dust or debris. For PET and glass bottles, the process is more intensive. PET bottles are first blown into shape from preforms using heated molds, while glass bottles go through a multi-step washing process that includes detergent cleaning, high-temperature rinsing, and sterilization with ozone-treated water. Once the containers are sanitized and ready for filling, they move along conveyor belts to the high-speed filling machines. These machines operate with incredible efficiency, using precision nozzles to dispense the exact amount of cherry Coca-Cola into each container. One of the biggest challenges in this step is ensuring that carbonation is preserved during filling. To prevent excessive foaming and carbonation loss, the filling machines use counter-pressure technology. This involves pressurizing the container with CO2 before filling it with the beverage, ensuring that the carbonation remains intact and that there is minimal oxygen exposure. As the bottles and cans are filled, they are closely monitored by sensors and automated quality control systems to ensure that the correct fill levels are maintained. Any underfilled or overfilled containers are automatically rejected from the line. The next critical step is sealing, where each container is securely closed to lock in freshness. For aluminum cans, an automated seaming machine places a lid on top of the can and crimps it into place, creating an airtight seal. For plastic bottles, tamper-evident caps are applied using high-speed capping machines, while glass bottles are typically sealed with either twist-off metal caps or traditional crown caps. Immediately after sealing, the filled containers go through a pasteurization or cold sterilization process depending on the packaging type and regional regulations. In some cases, cherry Coca-Cola undergoes flash pasteurization, where the beverage is rapidly heated and cooled to kill any potential microorganisms without altering the taste. However, for many markets, Coca-Cola products are aseptically filled. meaning that the entire bottling process is conducted under sterile conditions, eliminating the need for heat treatment. Once the sealing and sterilization process is complete, the bottles and cans move to the labeling and packaging stage. This is where branding and product information are applied to each container, ensuring that the final product meets regulatory requirements and maintains Coca-Cola's iconic visual identity. Now that the cherry Coca-Cola has been bottled and sealed, the next phase of the manufacturing process focuses on quality control and inspection. Every single can and bottle must meet Coca-Cola's strict global quality standards before it can be shipped to retailers. This process involves multiple layers of testing, from automated inspections on the production line to detailed laboratory analysis conducted by food scientists. Even the smallest deviation in taste, carbonation level, or packaging integrity can result in a batch being rejected, ensuring that only the highest quality product reaches consumers. The first step in quality control takes place immediately after the filling and sealing process. High-speed vision inspection systems are installed along the conveyor belts, using advanced cameras and sensors to examine each bottle and can for defects. These systems check for issues such as underfilled or overfilled containers, misaligned caps, dents in cans, or improperly applied labels. If a container does not meet specifications, it is automatically removed from the line by a rejection mechanism. This automated inspection process allows for the real-time elimination of defective products, preventing inconsistencies from reaching the market. Another crucial quality control measure is the carbonation and pressure test. Since cherry Coca-Cola's signature fizz is one of its defining characteristics, it is essential to ensure that each bottle and can contains the correct amount of dissolved CO2. To verify this, a random selection of containers is taken off the production line and placed into a specialized testing chamber where their internal pressure is measured. If the pressure falls outside the acceptable range, this could indicate improper carbonation levels, a sealing defect, or temperature fluctuations during the filling process. If an issue is detected, adjustments are made to the carbonation equipment to maintain consistency across the batch. Next, samples from each production run are sent to the on-site laboratory for detailed chemical and sensory analysis. Here, trained food scientists perform a variety of tests to confirm that the cherry Coca-Cola meets Coca-Cola's strict formulation guidelines. One of the first tests conducted is the Brix test, which measures the concentration of dissolved sugars in the beverage. Since cherry Coca-Cola has a carefully calibrated sweetness level, any deviation in the Brix measurement could indicate an incorrect syrup-to-water ratio, requiring adjustments in the proportioner. Another key laboratory test is pH analysis. The acidity of cherry Coca-Cola is a crucial component of its taste, and this is largely controlled by the phosphoric acid content. A pH meter is used to measure the beverage's acidity, ensuring that it falls within the required range. Any variation in pH can significantly affect the drink's flavor balance, so this test is performed regularly to maintain consistency. Sensory evaluation is another critical aspect of quality control. A panel of trained taste testers, known as a sensory panel, is responsible for conducting blind taste tests to ensure that each batch of cherry Coca-Cola matches the expected flavor profile. These experts are highly trained to detect even the slightest differences in sweetness, acidity, carbonation, and cherry flavor intensity. They compare samples from the production line with reference samples from previous batches, ensuring that the taste remains uniform across all locations. If any inconsistencies are detected, adjustments are made to the formulation or processing parameters before the product is released for distribution. Packaging integrity is also a major focus of the quality control process. Even if the beverage itself meets all specifications, the packaging must be flawless to ensure product safety and shelf stability. To test this, Random samples of filled bottles and cans undergo extreme stress testing. For plastic bottles, drop tests are conducted to simulate potential impacts during transportation. The bottles are dropped from various heights to ensure that they do not crack, leak, or experience cap failure. Cans are subjected to compression tests, where a machine applies controlled pressure to verify their structural integrity. If a can is too weak, it could deform or burst under normal handling conditions. If it is too rigid, it could indicate an issue with the aluminum thickness or the pressurization process. These tests help ensure that every container is durable enough to withstand shipping, storage, and handling by consumers. Another important quality control step is microbiological testing. Although cherry Coca-Cola's high acidity and carbonation naturally inhibit microbial growth, samples are still tested for the presence of bacteria, yeast, or mold. Microbiological testing is performed in a sterile laboratory environment where beverage samples are incubated under controlled conditions to detect any signs of microbial contamination. Even though Coca-Cola products are manufactured in sterile conditions, this extra layer of safety ensures that no contamination occurs at any stage of production. After all of these quality control tests have been completed, the final step before distribution is the batch coding and tracking process. Each bottle and can is printed with a unique production code that contains information about the manufacturing date, production line, and facility location. This allows Coca-Cola to track every product from the factory to store shelves. If an issue is ever discovered in a specific batch, this coding system enables rapid identification and recall of affected products. Once the cherry Coca-Cola has passed all quality control tests, the final phase of production involves packaging and distribution. This step ensures that the product is properly grouped, protected, and efficiently transported from the factory to retailers worldwide. The packaging process is highly automated and designed to handle the massive volume of cherry Coca-Cola produced daily while maintaining efficiency, accuracy, and product integrity. The first step in packaging is grouping the bottles and cans into multi-packs. Depending on the market and retail preferences, cherry Coca-Cola is sold in a variety of formats, including single cans, 6-packs, 12-packs, and larger 24-pack cases. The process begins with an automated system that arranges the bottles or cans into the correct configuration for packaging. High-speed robotic arms carefully align the containers into precise rows, ensuring uniformity before wrapping or boxing. These systems are programmed to adjust the layout based on production requirements, allowing flexibility in the types of multi-packs produced. For aluminum cans, a shrink wrapping system is used to bundle them together into multi-packs. The cans pass through a conveyor where they are tightly wrapped in a thin but durable layer of plastic film. This film is then heated in a specialized tunnel, shrinking it around the cans to create a secure and tamper-proof bundle. This method provides stability during transportation while allowing consumers to easily separate individual cans when needed. In some cases, paperboard carriers are used instead of plastic shrink wrap, particularly in regions where sustainability initiatives encourage the reduction of plastic packaging. These carriers are die-cut to hold the can securely while allowing easy removal. For plastic bottles, the process differs slightly. Many multi-packs of plastic bottles are held together using plastic rings or shrink-wrapped trays. Larger cases of cherry Coca-Cola bottles are placed into corrugated cardboard boxes for additional protection. The use of recyclable materials is prioritized wherever possible to reduce environmental impact. Coca-Cola has implemented sustainable packaging solutions such as biodegradable plant-based plastics and recyclable wrapping materials to minimize waste. Some factories have also introduced lighter weight PET bottles that require less plastic while maintaining the same durability, further contributing to environmental goals. Once the cherry Coca-Cola bottles and cans are securely packed, they move to the palletization stage. A palletizer is a large automated machine that carefully stacks the packaged products onto wooden or plastic pallets in an optimized arrangement for stability. This process ensures that products do not shift or fall during transport. Each pallet is carefully configured to maximize space while maintaining structural integrity. The palletizer is programmed to create stable layers of product, with each row strategically positioned to distribute weight evenly. After the pallets are loaded, they are wrapped with industrial-strength plastic film to keep them secure. This stretch wrapping process ensures that the products remain stable during transport. In some cases, pallets are reinforced with corner protectors for additional stability, particularly when shipping long distances. Some facilities also use robotic pallet wrappers, which automatically detect the height and dimensions of each pallet to apply the precise amount of stretch film required for stability without excessive material use. Once wrapped, the pallets are labeled with tracking codes and barcodes that contain critical shipment information, including the product type, batch number, expiration date, and destination details. These labels ensure that the inventory can be accurately tracked throughout the supply chain, reducing the risk of misdelivery or loss. The tracking system also allows retailers to quickly verify shipments upon arrival and enables Coca-Cola to monitor stock movement and demand trends. The next step is warehouse storage and inventory management. Once the cherry Coca-Cola pallets are prepared, they are transported via forklifts to massive storage warehouses. These warehouses are temperature controlled to protect the beverage from excessive heat or humidity, which could affect carbonation levels or packaging integrity. Temperature regulation is especially important in regions with extreme climates, as fluctuations in temperature could cause the CO2 in the beverage to expand or contract, potentially leading to leaks or compromised carbonation. Advanced inventory management systems track every pallet, using barcodes and RFID technology to ensure efficient organization and retrieval. These systems automatically log incoming and outgoing shipments, allowing real-time monitoring of stock levels. Warehouses are organized using automated retrieval systems that move pallets using robotic arms and conveyor systems, further increasing efficiency in high-volume distribution centers. Once the products are stored, the logistics and distribution phase ensures that cherry Coca-Cola reaches retailers and consumers as quickly as possible. The logistics team carefully plans delivery routes based on demand, ensuring that distribution centers and retail locations receive fresh stock on schedule. The distribution model varies depending on the region, with some locations utilizing central distribution hubs that serve multiple retailers, while others ship directly from production facilities to large supermarket chains and wholesalers. Trucks are loaded with pallets of cherry Coca-Cola according to a strict loading schedule, ensuring that the oldest inventory is shipped first to maintain freshness. The loading process is carefully coordinated to optimize space while keeping products stable during transit. Many of these trucks are refrigerated or climate controlled, particularly in warmer regions, to prevent heat exposure that could compromise product quality. In some cases, insulated truck liners are used instead of full refrigeration, allowing for temperature control without the added energy cost of refrigerated transport. The process begins with the sourcing of raw ingredients, including hazelnuts, sugar, cocoa powder, palm oil, skim milk powder, and vanillin. These ingredients are delivered to Nutella factories in massive quantities, requiring large-scale handling infrastructure. Hazelnuts, one of the key components of Nutella, are often sourced from Turkey and Italy, two of the largest hazelnut producers in the world. Upon arrival at the factory, hazelnuts are stored in enormous silos or temperature-controlled storage rooms to maintain their freshness. The silos are made of food-grade stainless steel and designed to protect the nuts from humidity and contamination, while allowing for precise dispensing into the production line. The first step in processing the hazelnuts is cleaning. Hazelnuts arrive in bulk shipments, often mixed with debris such as shells, stems, and dirt. To address this, the factory uses a series of cleaning systems that include vibrating screens, air classifiers, and magnetic separators. The vibrating screens shake the nuts to separate them from larger debris, while the air classifiers blow away lightweight impurities like husks and dust. Magnetic separators are also used to detect and remove any metallic particles that might have entered the shipment during harvesting or transport. Once cleaned, the hazelnuts undergo visual inspection using high-speed optical sorting machines equipped with cameras and sensors. These machines identify and remove any defective hazelnuts, such as those with discoloration, cracks, or signs of mold. After cleaning, the hazelnuts move to the roasting stage. Roasting is a crucial step in developing the rich, nutty flavor that characterizes Nutella. In the factory, this is achieved using massive industrial roasting ovens. These ovens are designed with rotating drums or conveyor belts to ensure even roasting. The temperature is carefully controlled, typically ranging between 280 and 320 degrees Fahrenheit, depending on the size and moisture content of the hazelnuts. Sensors monitor the temperature and time to ensure consistency, as over-roasting can lead to bitterness, while under-roasting can result in a lack of flavor. The entire roasting process is automated, and the equipment is designed for continuous operation to handle the high volume of hazelnuts required for production. Once roasted, the hazelnuts are transferred to grinding machines. These machines are equipped with heavy-duty stainless steel blades and rollers that crush the nuts into a fine paste. The grinding process occurs in multiple stages, with each stage further reducing the particle size of the hazelnut paste. In the initial stage, the nuts are coarsely ground into a chunky paste. In the subsequent stages, the paste is refined into a smooth consistency, with particle sizes measuring less than 30 microns. This ultra-fine grinding is essential for achieving Nutella's creamy texture. The equipment used in this process, such as colloid mills and ball mills, is highly specialized and designed to operate under high pressure and at precise speeds. The resulting hazelnut paste is collected in large stainless steel tanks, where it is stored at a controlled temperature to preserve its flavor and consistency. While the hazelnut paste is being prepared, the other ingredients are processed in parallel. Sugar, which provides sweetness to Nutella, is delivered to the factory in bulk containers or tankers. Upon arrival, the sugar is unloaded into silos, equipped with pneumatic conveying systems. These systems use air pressure to transport the sugar from the silos to the milling area, where it is ground into a fine powder. Industrial sugar mills are used for this purpose, and the grinding process ensures that the sugar particles are small enough to dissolve uniformly in the mixture. The factory also incorporates sieving systems to filter out any impurities or oversized sugar particles before they proceed to the blending stage. Cocoa powder, another key ingredient, undergoes a similar process. The cocoa powder is stored in sealed silos to protect it from moisture and contamination. Before being added to the Nutella mixture, the cocoa powder is sifted through vibrating screens to break up clumps and ensure a fine, even consistency. This step is crucial for achieving the smooth texture of the final product, as any clumps could create inconsistencies during blending. Palm oil, which gives Nutella its creamy consistency and prevents separation, is stored in large, temperature-controlled tanks. These tanks are equipped with heating elements to keep the oil in a liquid state, as palm oil tends to solidify at room temperature. The oil is pumped through insulated pipes to the mixing area, where it is carefully measured and added to the blend. The precise control of temperature and flow rate is essential to ensure that the oil integrates smoothly with the other ingredients. Skim milk powder, which adds a subtle dairy flavor and contributes to the creamy texture of Nutella, is stored in sealed containers or silos to prevent exposure to air and moisture. Before being used, the milk powder is sifted and screened to remove any lumps. Factories use advanced pneumatic conveying systems to transport the milk powder from the storage silos to the mixing area, ensuring that the ingredient is handled efficiently and hygienically. The blending process is the heart of Nutella's production, where all the prepared ingredients come together to form the final product. The blending tanks used in Nutella factories are massive, often with capacities of several thousand gallons. These tanks are equipped with high-speed agitators and temperature control systems. The hazelnut paste, sugar powder, cocoa powder, skim milk powder, palm oil, and vanillin are added to the tank in precise proportions, which are controlled by computerized dosing systems. These systems are programmed to weigh and dispense each ingredient accurately, ensuring consistency across batches. During blending, the mixture is heated slightly to help the ingredients combine more effectively. The temperature is carefully monitored, as excessive heat could alter the flavor and texture of the product. The blending tanks are designed to ensure even mixing, with agitators that create a vortex to incorporate all the ingredients thoroughly. The result is a homogeneous mixture with a smooth, creamy consistency. Once the blending process is complete, the mixture undergoes a refining stage. Refining is a critical step that ensures the final product is free of any graininess. The refining process takes place in multi-stage roller mills, which are equipped with heavy-duty steel rollers. These rollers apply immense pressure to the mixture, reducing the particle size of any remaining solids to less than 20 microns. This process not only enhances the texture of Nutella, but also improves its spreadability. The roller mills are fitted with precision sensors that monitor the pressure and temperature during refining, ensuring optimal performance. After refining, the mixture is transferred to the conching stage. Conching is a process borrowed from chocolate manufacturing and involves agitating the mixture in large, heated tanks for several hours. This process helps to further smooth the texture and enhance the flavor of the spread by allowing volatile compounds to evaporate and by evenly distributing the fats and solids. The conching tanks are equipped with paddles or rollers that knead the mixture continuously. The temperature and duration of conching are carefully controlled, as overconching could negatively affect the spread's consistency. The finished Nutella is then pumped into holding tanks, where it is kept at a controlled temperature until it is ready for packaging. These tanks are equipped with agitators to prevent separation and maintain the spread's uniformity. Before the Nutella is packaged, it undergoes a final round of quality control. Samples from each batch are tested for flavor, texture, color, and viscosity. The factory uses advanced laboratory equipment such as viscometers and spectrophotometers to ensure that the product meets the company's stringent standards. Any deviations from the desired specifications are identified and corrected before the product proceeds to the packaging stage. Packaging is the final step in Nutella's production process, and it is carried out with the same level of precision and efficiency as the earlier stages. The spread is pumped from the holding tanks into automated filling machines, which dispense precise amounts of Nutella into jars. The filling machines are equipped with high-speed nozzles that can fill hundreds of jars per minute. Each jar is made from food-grade plastic or glass and arrives at the factory pre-sterilized to ensure hygiene. The jars are sealed with tamper-proof lids, which are applied and tightened using automated capping machines. Once the jars are sealed, they are conveyed to labeling stations, where Nutella's iconic branding is applied. The labels include important information such as the lot number, production date, and expiration date, which are printed using high-speed inkjet or laser printers. After labeling, the jars are inspected by vision systems that check for defects such as misaligned labels or damaged seals. Any defective jars are automatically removed from the production line. The jars are then packed into cardboard cartons using robotic packing systems. These systems are programmed to arrange the jars in specific configurations to maximize space and protect the jars during transportation. The cartons are sealed and stacked onto pallets using robotic palletizers. The pallets are then wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. The entire packaging process is designed for high efficiency, with minimal manual intervention and maximum output. Throughout the factory, automation plays a key role in maintaining efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems are used to monitor and control every aspect of the production process. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. The factory is also equipped with advanced robotics and machinery that ensure smooth operation, from ingredient handling to final packaging. Hygiene and safety are top priorities in Nutella factories. Production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Air filtration systems maintain a clean environment by preventing airborne contaminants from entering critical zones. Employees follow strict hygiene protocols, including wearing protective clothing and washing their hands regularly. The factory is regularly inspected to ensure compliance with international food safety standards, guaranteeing that every jar of Nutella is safe for consumption. This intricate, highly automated process ensures that Nutella is consistently smooth, flavorful, and delicious, meeting the high expectations of its millions of fans worldwide. Every step, from the handling of raw ingredients to the final packaging, is a testament to the engineering and precision that go into creating this beloved spread. The result is a product that continues to delight consumers, one jar at a time. Peanut butter, a staple spread beloved worldwide for its creamy or crunchy texture, requires a sophisticated and highly organized manufacturing process to meet the demand for consistent quality and flavor. Behind every jar of peanut butter is an intricate factory process that starts with the raw peanuts and ends with precisely packaged jars ready for distribution. Let's take an in-depth look at the factory production process, exploring the machines, systems, and engineering techniques that make it all possible. The process begins with the sourcing of raw peanuts. These peanuts are typically grown in countries like the United States, China, India, and Argentina, which are among the largest producers of peanuts globally. Peanuts are harvested in vast quantities, cleaned and dried at their source before being shipped to peanut butter manufacturing facilities. Factories require a consistent supply of high-quality peanuts, and to ensure that the raw peanuts are often tested upon arrival for size, moisture content, and overall quality. This ensures only the best peanuts are used for processing. Upon arrival at the factory, peanuts are stored in massive silos or bins designed specifically for food products. These silos are constructed from food-grade stainless steel or coated steel to prevent contamination and ensure proper hygiene. Inside the silos, the peanuts are protected from moisture, pests, and temperature fluctuations. These storage systems are equipped with conveyor systems that efficiently transfer peanuts from the silos to the initial cleaning and processing stages. The first step in processing peanuts is cleaning. Even though peanuts are partially cleaned at their source, factories implement a rigorous cleaning process to ensure no foreign materials or impurities remain. Vibrating screens are used to remove debris such as dirt, stones, and small sticks. Air classifiers blow air through the peanuts to remove lighter debris such as peanut skins or husks. Magnets are also employed to extract any metallic impurities. Optical sorting machines equipped with cameras and sensors scan each peanut as it moves along a conveyor belt, automatically removing any defective peanuts, including those with discoloration, mold, or deformities. After the cleaning process, the peanuts proceed to the roasting stage. Roasting is a critical step in peanut butter production, as it develops the rich, nutty flavor that defines the final product. Factories use industrial roasting ovens to roast the peanuts at controlled temperatures. These ovens come in two main types: batch roasters and continuous roasters. Batch roasters are used for smaller production lines, while continuous roasters, which use conveyor belts to move peanuts through a heated chamber, are used for larger scale operations. The temperature in these roasters typically ranges from 300 to 350 degrees Fahrenheit. The roasting process is closely monitored with temperature sensors and automated control systems to ensure the peanuts are roasted evenly. If some peanuts are over-roasted, they can turn bitter, while under-roasted peanuts may lack flavor. The level of roasting can also be adjusted depending on whether the final peanut butter will have a mild or more robust taste. Once roasted, the peanuts are cooled to stop the cooking process. Cooling is achieved by passing the roasted peanuts through chambers with powerful fans or cool air blowers. This step is crucial because it prevents the peanuts from continuing to cook, which could lead to inconsistencies in flavor. Some factories also use a water spray system to rapidly cool the peanuts, though this is less common as it can add moisture to the product. The cooling systems are designed to operate continuously to keep pace with the output of the roasting ovens. With the peanuts roasted and cooled, the next step is to remove their skins and separate the kernels. Skin removal is done using blanching machines. These machines have rotating drums or abrasive rollers that rub the peanuts, causing the thin outer skin to flake off. Some systems use steam blanching, where the peanuts are exposed to high-pressure steam to loosen the skins before mechanical removal. After blanching, the peanuts pass through air classifiers that blow away the loose skins, leaving behind clean peanut kernels. Factories also use gravity separators to sort peanuts by size and density, ensuring that only uniform peanuts proceed to the grinding stage. Before grinding, the peanuts are inspected again for quality. This is done using high-speed optical sorters that ensure any remaining defective peanuts are removed. Factories often have automated weighing and proportioning systems at this stage to determine the exact amount of peanuts needed for each batch. This level of precision is crucial for maintaining consistency in the flavor and texture of the peanut butter. The grinding process is the heart of peanut butter production. The roasted peanuts are fed into industrial grinders, where they are crushed into a fine paste. This process happens in multiple stages, beginning with coarse grinding and followed by finer grinding. The equipment used for this includes hammer mills and roller mills, which are specifically designed to reduce the peanuts into small, uniform particles. In many factories, the particle size is reduced to less than 20 microns, which is smaller than the diameter of a human hair. Achieving such a fine consistency is essential for the creamy texture that many consumers expect from peanut butter. For crunchy peanut butter, the process is slightly different. In these cases, a portion of the peanuts is coarsely ground and set aside before the final blending stage. These larger peanut pieces are later mixed into the smooth paste to create the characteristic crunchy texture. To prevent the peanut butter from separating, stabilizers such as hydrogenated vegetable oils or palm oil are added during the grinding process. These oils help bind the natural peanut oils to the solid peanut particles, ensuring a smooth and stable product that doesn't separate in the jar. Salt and sugar are also added at this stage to enhance the flavor of the peanut butter. Factories use precision dosing systems to measure and add these ingredients in exact proportions, ensuring every batch has the same taste. After grinding, the peanut butter is sent through a mixing stage, where it is further blended in large stainless steel tanks equipped with high-speed agitators. This stage ensures that the stabilizers, salt, and sugar are evenly distributed throughout the peanut butter. These tanks are often heated slightly to keep the peanut butter at the right consistency for mixing. The temperature is carefully controlled, as overheating can alter the flavor or texture of the peanut butter. Once the mixing is complete, the peanut butter undergoes quality control checks. Samples from each batch are tested in an on-site laboratory for flavor, texture, and consistency. Advanced instruments, such as viscometers, are used to measure the viscosity of the peanut butter, ensuring it meets the desired standards. Factories also use particle size analyzers to confirm that the peanut butter's texture is smooth and uniform. These quality checks are critical, as even slight variations can impact the final product's appeal to consumers. The final step in the manufacturing process is packaging. The peanut butter is pumped from the mixing tanks to filling machines, where it is dispensed into jars. These filling machines are capable of handling thousands of jars per hour, ensuring high efficiency. The jars, typically made of food-grade plastic or glass, arrive at the factory pre-cleaned and are sterilized again before filling. The filling nozzles are designed to dispense precise amounts of peanut butter into each jar, ensuring uniform weight and volume. Once the jars are filled, they move to the capping machines, where tamper-proof lids are applied and tightened. After capping, the jars are conveyed to labeling machines, which apply the brand's signature labels, along with lot numbers and expiration dates for traceability. Vision systems inspect each jar to ensure that the labels are correctly applied and that there are no defects in the seals or packaging. The jars are then packed into cardboard boxes using robotic packing systems. These robots are programmed to arrange the jars in specific configurations to optimize space and protect the jars during transportation. The boxes are sealed and stacked onto pallets using automated palletizing systems. Finally, the pallets are wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. Throughout the entire production process, automation plays a vital role in maintaining efficiency and consistency. Factories are equipped with programmable logic controllers, PLCs, and supervisory control and data acquisition, SCADA systems, that monitor and control every aspect of production. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. Robotic systems handle many tasks, from sorting and cleaning peanuts to packaging the final product, reducing the need for manual labor and ensuring precision. Hygiene and safety are also top priorities in peanut butter factories. The production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Positive air pressure systems prevent airborne contaminants from entering critical zones, while strict hygiene protocols ensure that employees maintain cleanliness throughout the production process. The entire facility is regularly inspected to comply with international food safety standards, ensuring that every jar of peanut butter is safe for consumption. Peanut butter production is a complex and highly technical process that relies on advanced machinery, precise engineering, and rigorous quality control. From the cleaning and roasting of peanuts to the grinding, mixing, and packaging of the final product, every step is designed to create a spread that is smooth, flavorful, and consistent. Factories operate with remarkable efficiency, producing thousands of jars per day to meet the global demand for this versatile and beloved product. Strawberry jam production is a fascinating and highly engineered process that combines precision machinery with time-tested techniques to create a smooth, fruity spread. At the core of this process are high-quality strawberries, sugar, pectin, and citric acid, all carefully handled and processed to achieve the perfect consistency and flavor. Inside a modern jam factory, every step is optimized for efficiency, consistency, and food safety. The process begins with the selection and delivery of fresh or frozen strawberries. Factories typically source strawberries from local farms or large-scale suppliers. Frozen strawberries are often preferred for large-scale production because they are preserved at peak ripeness, ensuring consistent flavor year-round. The strawberries arrive in bulk containers and are stored in cold rooms or freezers to maintain their quality until processing begins. Before entering the production line, the fruit undergoes a thorough cleaning process. This includes washing the strawberries in large tanks filled with filtered water, where gentle agitation removes dirt, debris, and any residual pesticides. Once cleaned, the strawberries pass through optical sorting machines. These machines use cameras and sensors to identify and remove defective or discolored fruit. Advanced systems can even detect minute imperfections, ensuring that only the highest quality strawberries make it into the jam. After sorting, the strawberries are sent to cutting or mashing machines, depending on the desired jam texture. For chunkier jams, strawberries are coarsely chopped, while for smooth spreads, they are mashed or pureed into a uniform consistency. The fruit then enters large stainless steel cooking kettles or continuous cooking systems. In these vessels, the strawberries are combined with sugar, which not only sweetens the jam, but also acts as a natural preservative. The sugar is added using automated dosing systems that measure precise quantities to ensure consistent flavor. Pectin, a natural thickening agent derived from fruit, is added to help the jam set. Citric acid is also incorporated to balance the sweetness and enhance the fruit's natural flavor. The mixture is slowly heated, with temperatures reaching up to 220 degrees Fahrenheit to activate the pectin and achieve the ideal gel-like consistency. During cooking, the jam undergoes constant agitation to prevent scorching and ensure even heating. Steam-jacketed kettles or vacuum cookers are often used, as they allow for rapid and uniform heating. Modern vacuum systems are particularly advantageous because they enable cooking at lower temperatures, preserving the fresh flavor and bright color of the strawberries. Throughout the cooking process, sensors monitor the temperature, pH levels, and viscosity of the jam, ensuring that the final product meets strict quality standards. Once the jam reaches the desired consistency, it is pumped through a series of filters to remove any seeds or large pieces if a smoother texture is desired. The finished jam is then transferred to filling machines. These machines dispense precise amounts of jam into sterilized glass jars or plastic containers. The jars are immediately sealed with tamper-proof lids to maintain freshness and prevent contamination. After sealing, the jars are passed through pasteurization tunnels, where they are briefly heated to destroy any remaining microorganisms. Finally, the jars are labeled, inspected, and packed into cartons using robotic packaging systems. The entire process is highly automated, ensuring efficiency and consistent quality from the arrival of fresh strawberries to the delivery of jars to store shelves. This seamless blend of traditional cooking techniques and advanced technology ensures that every jar of strawberry jam is rich in flavor, perfectly textured, and safe for consumers to enjoy. Honey, often called nature's golden nectar, offers more than just sweetness. It nourishes the body with its rich nutritional properties. In this video, we'll explore a traditional bulk honey harvesting process that's both fascinating and meticulous. Stick around, or those stingy honeybees might come for you. When a bee egg hatches, the hive comes alive. A legless, featureless grub resembling a gummy worm emerges. These grubs thrive in hexagonal wax cells that not only protect them, but also store essential food reserves for winter and maintain the hive's temperature and structure. Bees flutter from flower to flower, using their black tongues to gather nectar from blossoms. This nectar is stored in their honey stomach, separate from their digestive system. Harvesting this treasure demands careful preparation. Enter the beekeeper, clad in protective gear and armed with tools like a hive tool and a gentle bee brush. Smoke calms the bees, ensuring an efficient and respectful harvest. The hive frames are separated, brushed free of bees, and transferred into neatly arranged boxes. The hive tool is vital for separating the frames, while a gentle bee brush is used to handle the bees without harming them. Each hive is carefully examined, with the honey-filled frames separated and skillfully transferred to neatly arranged boxes. Watching this, you'll admire one fearless woman who harvests honey without any protective gear at all, something most of us wouldn't dream of trying. The honey hive boxes are now transported to the factory, where they are systematically moved through the first step of processing, removing the top layer of the hive. This natural and magical goodness is packed with rare benefits that will transform your healthy eating plans. Stick around, I'll tell you more in a moment. This process is all done with the help of some common machinery. First, the honeycombs are set, and the machine removes the outer top layer from both sides of the honeycombs, maintaining its pure golden honey. This step is crucial to access the honey, as it's not easy to extract because of the bees' creativity. The boxes begin to release honey at some points, but the major quantity remains inside the combs, which are transported to further processing machines. One by one, each honeycomb tray is placed inside the machine to open the hives and access all the honey the bees were hiding. Then comes the spinning machine, which extracts every drop of honey and transfers it into collectors. I once witnessed a similar rare spinner in Turkey, the second largest producer of pure honey. The spinning process extracts the last drops of honey and thoroughly cleans the hives, making them ready for reuse. The mixed honey is churned a little and passed through built-in sieves, resulting in pure, golden, flawless honey. Next, the honey is stored in large containers at an optimal temperature to maintain fluidity for pouring. The process begins with an automated filling machine. The jars are aligned under a filling nozzle to get the desired amount with minimal spillage or waste. At the sealing station, automated arms place lids on the jars, ensuring everything runs smoothly thanks to automation. Consuming a spoonful of honey before meals can soothe the stomach and improve digestion with its enzymes and antioxidants. Stay healthy and enjoy this natural nectar. You're now inside a honey spoon factory where they handpick the best honey for its amazing flavor. They don't just stop at regular spoons. They mold honey into cute spoon shapes using plastic or silicone. Each spoon gets sealed up tight with fancy film or foil, like wrapping a little gift, so you only grab, unpack, and use the honey without creating any mess. They pack them up in boxes or trays, ensuring each spoon travels safely until it reaches your kitchen. Liquid jam and biscuits create a delicious duo that's both flavorful and wholesome. The natural sweetness of jams enhances the taste of biscuits, adding a rich caramel-like depth that perfectly complements their crunchiness. Need something savory and crispy after a sweet treat? Look at these delicious sandwiches being prepared in no time. Say cheese slice and consider it all done. Donut cakes are the ultimate versatile treat, enjoyed in so many ways. They kickstart mornings perfectly with coffee or tea, adding a sweet touch to breakfast. They're also the go-to for satisfying sweet cravings anytime. Whether you love cream-topped sponge cakes or thoroughly chocolate-dipped donuts, you've got it all. And we don't need to exaggerate the appeal of chocolate dripping. It's anyone's first pure love. Nobody's going to disagree, right? Hey buddies, welcome to the inside scenes of some bulk fruit factories. Let's see how they process and handle so much bulking. First, some good factories use common food sanitizers to clean the water and fruits from outside. Chlorine, the real MVP, gets rid of nasty bacteria, viruses, and fungi. Sometimes they add citric acid to balance the water's pH and make the sanitizers work even better. After a good rinse, the pineapples ride the conveyor belt for a quick dry. Check out those blades. They are going to peel the pineapples like pros. A machine pushes the tough core out of the way, and then skilled workers cut the fruit into the sizes customers want. After slicing, a little but quick bath is necessary. The conveyor belts give the fruit a gentle shake to remove extra moisture without messing up its texture. Finally, they use moderate air pressure to ensure all moisture is gone, keeping the fruit fresh and extending its shelf life. If you're curious about why they fuss so much about keeping fruit dry before packaging, it's quite obvious. Moisture isn't just about making fruit soggy, it disrupts the osmotic balance within fruit tissues, breaking down cell membranes and causing unwanted degradations. After the pineapple chunk's frozen adventure, you'll see a new fluffing technique that separates each chunk, giving it its own uniqueness. Come around, you all raspberry lovers. You're going to witness the largest harvesting and freezing of raspberries you have ever seen. Using fruit, harvesters like these beasts for picking berries in the fields offers significant advantages to fruit processing factories and labor. These machines promise efficiency but demand a skilled touch. Therefore, workers undergo specialized training to navigate the complexities of this crucial job. These machines struggle with selective harvesting and can sometimes result in picking some unripped berries as well. But with the help of the experts, no ruined berry is going to pass through. As soon as the raspberries arrive in the facilities first, the experts carefully remove the ruined berries, and then they get a thorough rinse to get rid of any dirt or germs. After that, they go on the conveyor belt to dry off properly and are frozen right away. Here, the same separating techniques are applied to the frozen raspberries, so they do not stick to each other or make a cluster. These belts have thorough vibrators to fluff the berries. All together, and look, every berry is seen as an individual pack of deliciousness. If it seems satisfying to you and that's your vibe, we can be best friends because we are dedicated to show you the bulk factory processes. Want to stick together? Come on, subscribe to our channel and hit that notification bell to keep watching our upcoming videos. Some people still chose to go for old school methods for some delicate tasks, like picking fruit from trees so they won't get damaged. Their struggle leads them to transport the entire fresh stock of these fruits towards the facilities for further processing. Skilled workers use sharp knives to carefully cut open durian fruit as they are thoroughly cleaned. Again, these workers beautifully collect the inner edible flesh of the fruit in separate baskets. And here, a high-tech refractometer is used to measure the fruit's sweetness to make sure it's just right. As soon as the fruit pulp freezes at the right temperature, a bunch of workers get their gloves on to chop them into equal and smaller chunks. Now the fruit chunks are going in the freezers again to get the required consistency. Have you ever tried durian chips? They are quite famous in Thailand and Malaysia. I haven't tried yet, but I would like to give them a try. Look at that creamy yellow batter. It's going to cover the entire durian chunks. This is going to make the durian even more delicious. Some people often call it the king of fruits because of its rich custard-like texture and sweet, slightly nutty taste. A few people love it for its exotic flavor, while others find it unforgettable. After a thorough drying, the durian chunks are packed into small trays for easy and perfect serving. Did you ever notice how new harvesting machines are making big money for businesses? These high-tech tools are cutting down on labor costs, speeding up the harvesting process, and ensuring the fruit is of really high quality. They're also super accurate, which means less waste, and they're better for the environment. These machines are designed to move smoothly through the fields, gently shaking the bushes to release the ripe blueberries. As the blueberries fall off, the harvester's high-speed conveyor belts collect them efficiently. Each day, these machines can pick tons of blueberries, covering a large area much faster than manual picking. This efficiency not only speeds up the harvesting process, but also ensures the berries are collected at their peak ripeness. Such modern machines also help maintain the quality of the blueberries, ensuring they reach consumers fresh and delicious. Now, these carriers are going to take them with full responsibility and care to the washing facility. So, we are here in this massive, bustling factory where handling heaps of berries is an effortless breeze made possible only by cutting-edge technology. Now, we'll let these berries get a much-needed, thorough wash. Even the laziest bunch will be amazed by the incredible benefits of these purple powerhouses. These berries can supercharge brain function and memory, keeping your mind sharp and focused. These folks are donned in gloves as they expertly sort through the berries, swiftly sidelining any damaged ones. Freezing berries before packaging maintains their nutritional value, ensuring you get all the health benefits as if they were freshly picked. Every time we open a can or packet of frozen berries, we will be amazed by the quality fruit inside and thank them. Look at those experts tirelessly working and sorting these blueberries at different stages to give us the best experience. Did you know there are over 1,000 varieties of mangoes worldwide? That's right, and I know nothing about them. Just eating sweet mangoes is enough for me. These skilled workers use specialized blade cutters to carve mangoes into precise segments. Then, a refreshing bath ensures that any remaining latex from the peel, which can cause irritation or allergic reactions, is thoroughly cleaned off. These cutters transform the mangoes into bite-sized pieces, ensuring you get the full enjoyment of every juicy morsel without any hassle. This conveyor belt is equipped with vibrations, and there's a solid reason behind it. It ensures that any lingering water droplets are completely dried off, while the continuous shaking keeps them separated from each other. Now, they are being flash frozen in giant freezers to lock in all that incredible freshness. As they are carefully packaged into large boxes, workers keep an eagle eye, ensuring each box is filled to perfection. Peaches. Only high-quality peaches are selected for their cut in factories precisely. Their superior quality means better preservation. So, in this esteemed factory, things get started by removing the tough pit from inside the peaches. Razor-sharp precision blades skillfully transform these peaches into perfectly sized, small, juicy pieces. Ever wonder why cans are the top choice for preserving peaches? The canning process seals those juicy peaches in an airtight environment, shielding them from pesky, unwanted contaminants. This airtight seal is a game changer, extending the shelf life of peaches to even years without spoilage. While some peaches are chopped into tiny bits and flash frozen to keep them fresh throughout their usage, the vibrations incorporated in freezing help expose more surface area to the cold air, leading to quicker freezing. Also, it keeps the chunks separated from each other. As I keep on telling this, you must take an idea how important bananas are. Did you know that bananas are fantastic for reducing and preventing muscle cramps and spasms? So, if you're hitting the gym or just dealing with those pesky nighttime leg cramps, grabbing a banana can be your secret weapon. Even if it's in the form of banana chips, it's super delicious. Now, the cantaloupe is being expertly peeled by this skilled worker, with every bit of skin carefully removed. With about 90% water content, cantaloupe is an incredibly hydrating fruit, perfect for keeping you refreshed on a hot day. Moreover, it is a fantastic pick if you want to drop weight as well. First, these papayas get a thorough wash, scrubbing off every bit of dirt. Once revealing that luscious fruit inside, the seeds are expertly removed, and with a few swift cuts, the papayas are transformed into perfect, bite-sized pieces. I hope you've enjoyed this video containing dozens of fruits getting bathed, peeled, sorted, and frozen right away. It's also satisfying, no matter if you like these fruits or not. Some people might be allergic to them, but you will agree that watching anything in so much bulk quantity always gives a positive vibe. Ready I am about how those ready meals we pick up at the store are made in factories. Yes, these massive factories buzz with non-stop energy, churning out thousands of meals in mere minutes. It all kicks off with pots filled with just the right amount of top-notch rice. As the water gets added, the pots are sealed up tight, letting the rice soak up the moisture and settle perfectly. Once it's the right time for cooking, the machines gently but firmly hold those pots, turn them upside down to drain off the water using sieves. Now, the fresh water is being added to these pots to cook the rice up to perfect temperature and consistency. A robotic arm snaps the steamer's lid into place, and then these steam cookers roll out, getting seals attached to each pot as they go. Precise temperatures keep things from going wrong, avoiding any overcooking or undercooking. Of course, when the rice is perfectly cooked, robotic arms step in again. They carefully transfer the pots onto rolling iron rods that guide them along the conveyor belt. It's all automated here, with no human hands involved in the cooking process. That is pretty cool, right? Rice is cooked and all set to pour into the trays, so let them fill the hopper first. After rice, crispy chicken pieces are added to the trays to complete the meal box, along with pouring the sauces. Hey, it's not just one sort of meal box being prepped. You will see meal boxes filled with veggies and irresistible gravy. Boxes are filled, so before sealing the meal boxes, they are going to freeze these trays so they will remain fresh, flavorful, and preserved until you hit the store shelf and grab your favorite meal tray. As these trays glide along the conveyor belt to the sealing station, who wants to deal with anything less than 100% hygienic? That's why this sealing station is spotless, with super strict cleaning routines to keep every seal perfect and free from any contaminants. Now, these meal trays are all decked out in their perfect wrap and sealed tight. Of course, after sealing, the trays roll over to the labeling station, where they get tagged with all the key details, like brand name, ingredients, and expiry dates. Once these boxes are packed to perfection, this last stop ensures each box is tightly sealed and ready to roll out. I am sure that my fitness enthusiasts are eager to witness how their daily salad trays are crafted in factories. Pile on a generous serving of fresh green veggies, keeping everything perfectly separated. Tender grilled meat slices are added too, taking the game to the next level. And since healthy eats can't skip eggs, they're added as well. These machines portion out spaghetti into trays, giving each one just the perfect quantity. Then the trays cruise down the conveyor belt to the sauce station, where machines drizzle a rich tomato-based sauce all over the spaghetti, making sure each tray gets a big splash. Before we get into how your favorite crunchy banana chips are made, check out how these workers are sorting them to make sure every banana stays top-notch. When the bananas roll in on conveyor belts, they are peeled efficiently without damaging that delicate, crucial part. Why go for green bananas instead of ripe ones? If this ever clicks for you, it's pretty straightforward. Unripe bananas have a firmer texture and less sugar, which gives the chips that perfect crunch. Now, these peeled bananas get sliced into thin, even pieces by these incredible slicing machines. After a wash bath, these slices are checked to make sure they're just the right thickness. The hot oil makes them crunchy and delicious, and of course, the crew rocks face masks and gloves to stay safe. The chips hit another conveyor belt to drain off excess oil and dry out, making them extra crispy. Once dried, the chips get seasoned with their tasty signature flavors, ensuring every chip is perfectly seasoned. Of course, any overcooked chips are sorted out to keep your snack game strong. Finally, the chips get sorted into perfect portions by this huge, high-tech portioning machine. This fascinating machine makes sure every packet has just the right amount. After savoring those hearty meals, don't you think it's time for something sweet to wrap things up? The filling we all love with every crunchy bite starts with some secret ingredients mixing up in this huge machine, where sugar, coconut, and creamy butter team up to create that unbeatable flavor. Once the thick mixture is ready, it gets sliced into perfect pieces by these high-tech blades. It's time for the real treat. These bars are about to take a dip in a rich, flowing chocolate waterfall. And of course, it's crucial to take notes to make sure everything's on point. The chocolate coats each bar just perfectly, giving it that glossy, mouth-watering finish we just can't get over. This is exactly where they get their irresistible chocolatey vibe. So, after their chocolatey bath, they glide through a drying tunnel where some cool air helps the chocolate set, creating a crispy, delicious shell. I'm sure you're just as curious as I am about how those ready meals we pick up at the store are made in factories. Yes, these massive factories buzz with non-stop energy, churning out thousands of meals in mere minutes. It all kicks off with pots filled with just the right amount of top-notch rice. As the water gets added, the pots are sealed up tight, letting the rice soak up the moisture and settle perfectly. Once it's the right time for cooking, the machines gently but firmly hold those pots and turn them upside down to drain off the water using sieves. Now, the fresh water is being added to these pots to cook the rice up to the perfect temperature and consistency. A robotic arm snaps the steamer's lid into place, and then these steam cookers roll out, getting seals attached to each pot as they go. Precise temperatures keep things from going wrong, avoiding any overcooking or undercooking. When the rice is perfectly cooked, robotic arms step in again. They carefully transfer the pots onto rolling iron rods that guide them along the conveyor belt. It's all automated here, with no human hands involved in the cooking process. That is pretty cool, right? Rice is cooked and all set to pour into the trays, so let them fill the hopper first. After rice, crispy chicken pieces are added to the trays to complete the meal box, along with pouring the sauces. Hey, it's not just one sort of meal. Boxes are being prepped. You will see the meal boxes filled with veggies and irresistible gravy. Boxes are filled, so before sealing the meal boxes, they are going to freeze these trays so they will remain fresh, flavorful, and preserved until you hit the store shelf and grab your favorite meal tray. As these trays glide along the conveyor belt to the sealing station, who wants to deal with anything less than 100% hygienic? That's why this sealing station is spotless, with super strict cleaning routines to keep every seal perfect and free from any contaminants. Now these meal trays are all decked out in their perfect wrap and sealed tight. Of course, after sealing, the trays roll over to the labeling station, where they get tagged with all the key details like brand name, ingredients, and expiry dates. Once these boxes are packed to perfection, this last stop ensures each box is tightly sealed and ready to roll out. I am sure that my fitness enthusiasts are eager to witness how their daily salad trays are crafted in factories. Pile on a generous serving of fresh green veggies, keeping everything perfectly separate. Tender grilled meat slices are added too, which will take the game to the next level. And since healthy eats can't skip eggs, they're added too. These machines portion out spaghetti into these trays, giving each one just the perfect quantity. Then the trays cruise down the conveyor belt to the sauce station. Here, machines drizzle a rich tomato-based sauce all over spaghetti, making sure each tray gets a big splash. Before we get into how your favorite crunchy banana chips are made, check out how these workers are sorting them to make sure every banana stays top-notch. When the bananas roll in on conveyor belts, they are peeled efficiently without damaging that delicate, crucial part. Why go for green bananas instead of ripe ones? If this ever clicks for you, it's pretty straightforward. Unripe bananas have a firmer texture and less sugar, which gives the chips that perfect crunch. Now these peeled bananas get sliced into thin, even pieces by these incredible slicing machines. After a wash bath, these slices are checked to make sure they're just the right thickness. The hot oil makes them crunchy and delicious, and of course, the crew rocks face masks and gloves to stay safe. The chips hit another conveyor belt to drain off excess oil and dry out, making them extra crispy. Once dried, the chips get seasoned with their tasty signature flavors, ensuring every chip is perfectly seasoned. Of course, any overcooked chips are sorted out to keep your snack game strong. Finally, the chips get sorted into perfect portions by this huge high-tech portioning machine. This fascinating machine makes sure every packet has just the right amount of chips. After savoring those hearty meals, don't you think it's time for something sweet to wrap things up? The filling we all love with every crunchy bite comes first. Some secret ingredients mix up in this huge machine where sugar, coconut, and creamy butter team up to create that unbeatable flavor. Once the thick mixture is ready, it gets sliced into perfect pieces by these high-tech blades. It's time for the real treat. These bars are about to take a dip in a rich, flowing chocolate waterfall. The chocolate coats each bar just perfectly, giving it that glossy, mouth-watering finish we just can't get over. This is exactly where they get their irresistible chocolatey vibe. After their chocolate bath, they glide through a drying tunnel where some cool air helps the chocolate set, creating a crispy, delicious shell. The chill time helps them set just perfectly, giving them a flawless finish. It's crucial to keep tabs on the temperature, as it makes sure to prevent any melting or uneven coating, so every bite stays deliciously consistent. Once they're spot on, the bars are carefully sealed and packed. Each one is placed in its box, all set to hit the shelves and bring that sweet satisfaction. Who asked for pasta factory automation? Well, here we are, friends, watching the very common flour getting transformed into amazing pasta shapes. It all starts from gathering and processing the durum wheat to make flour for pasta. The durum wheat rolls into the factory and gets special treatment. The quality control crew makes sure it's spotless and pest-free. Then it goes through cutting-edge cleaners that kick out any chaff, stones, or trash, leaving only the finest golden grains ready to shine. Time to level up those grains into semolina flour. They hit up some next-level mills that grind them into the ultimate pasta base. The flour gets a sifting session to smooth out any lumps and get it looking just right. Finally, it's bagged up, sealed tight with all the details, and ready to roll out to pasta makers. In order to get the best and lump-free pasta at the end, these people use high-end blending machines that mix all the necessary dry and wet ingredients in the right ratios. This way, they get a perfect blend without overworking the dough. Kneading it well is necessary to build up the gluten and get that smooth, stretchy vibe. Fancy machines handle this automatically to keep things on point. Rolling the dough through a sheeting machine into thin, even sheets is making me even more excited to watch my favorite pastas getting in shape. This machine can tweak the thickness of any pasta type, moving those sheets through cutting machines or dies to shape them into whatever pasta you're going for: spaghetti, fettuccine, or another style. They're running the dough through cutters to get it into those iconic pasta shapes. These machines can be adjusted to fit different shapes and sizes. At last, the pasta is set on drying racks or conveyors that evenly dry it with advanced technology, keeping everything perfect. Advanced machines use temperature and humidity-controlled drying rooms or tunnels to speed up the process and ensure everything dries evenly. Machines and labor keep an eye on humidity levels to prevent moisture buildup, which can cause mold or spoilage. Now it's time to sort the pasta into uniform batches with sorting machines to keep things consistent. You're watching the amazing technology-based advanced machines responsible for making batches that then transfer into separate chambers. Robotic arms easily pick the calculated pasta every time for packing. First, the machines seal the pasta strips in a transparent plastic wrap to make sure the pasta stays safe and fresh during its entire shelf life. Finally, sealing machines pack it up tight with nitrogen flushing to keep it fresh and spoilage-free. Attached with labeled boxes, it's loaded into cartons using advanced machinery for shipping. Pasta is like a flavor playground with its endless shapes and textures. From classic spaghetti to fancy ravioli, each type adds its flair to your meal. It's a go-to that makes every dish pop with delicious vibes. I strongly agree with that. I've lived my whole life depending on them and only them. As you can see, the dough gets rolled into smooth sheets and then cut or shaped into all kinds of awesome designs with top-notch machines. It's where precision and creativity collide to turn simple dough into pasta magic. Pasta lovers, you're going to watch more shapes get rolled out of the amazing machines, so maybe you just hit the like button to motivate us. After shaping the smooth pasta dough just right, the pasta shapes are spaced on a conveyor belt for the next stage. They travel through a tunnel where the steam is all set to get these pastas almost ready for your every cuisine. In the perfectly controlled environment, the pasta gets its precise steaming process, ensuring it reaches the perfect, yummy, soft, and delicious texture. Once it reaches the required consistency, it's ready to be packed and shipped out. Tortiglione is a standout pasta with its cool twist and ridged vibe. It's like penne, but with deep spiral grooves that give it a unique look. Those ridges aren't just for show, they grab onto sauces like a pro, making it perfect for chunky, creamy, or meaty sauces. With its bold texture and flexible shape, tortiglione shines in classic Italian recipes and new inventive dishes. Macaroni is the ultimate elbow-shaped pasta with a slight curve, giving it that iconic look. All this magic is possible due to those amazing machines that churn out the pasta dough like that every time. It comes in smooth and ridged versions, but either way, it's perfect for scooping up sauces thanks to its hollow center. It cooks fast and keeps its shape, making it a go-to for creamy or chunky dishes. Macaroni is perfect in classics like mac and cheese and shines just as bright in pasta salads and hearty soups like pasta and fagioli. This careful packing process ensures that every box of pasta reaches consumers in perfect condition, ready to be enjoyed in all its delicious, perfectly cooked glory. I love pasta. I know you love it too. So does every second person in the United States. That's the reason every year, just a single person consumes 6 to 7 pounds of pasta alone, based on recent research. That's quite a number. Ice cream is a legendary dessert that never goes out of style, thanks to its rich, creamy vibe and endless flavor options. Made from a blend of milk, cream, and sugar, it's churned to perfection for that smooth, velvety goodness. Each bite is something to die for, with flavors from classic vanilla and chocolate to trendy ones. Whether you're going for a cone, cup, or stick, ice cream is the ultimate comfort food that always hits the spot. Fried mushrooms coated in creamy sauce and breadcrumbs are a total vibe, mixing crunch with smooth, savory goodness. The mushrooms get dunked in a lush, velvety sauce that enhances their flavor. Then they're covered in golden, crispy breadcrumbs that add a satisfying crunch. Frying them just right means you've got juicy, tender mushrooms inside a crispy, flavorful shell. It's the ultimate snack or side that's got the perfect mix of textures and tastes, making every bite a next level experience.